It appeared like a whisper in the void, a flicker of existence that lingered only briefly before vanishing, leaving nothing but questions and awe in its wake. For years, astronomers trained their most powerful telescopes on Fomalhaut b, a colossal exoplanet circling a star of unusual brilliance some 25 light-years from Earth. They called it the zombie planet, a name that captured the eerie strangeness of its behavior. Unlike anything they had encountered before, it seemed alive and dead at the same time, a ghostly presence in the vastness of space. First glimpsed by the Hubble Space Telescope in 2008, Fomalhaut b shimmered with an ethereal glow like light diffused through a delicate veil of fog. Yet by 2014, it had disappeared entirely. No orbit, no planetary body, nothing remained where the speck of light had been. Speculation ran wild. Some scientists argued it had never been a planet at all, merely the luminous remains of a titanic collision, two massive worlds meeting in a catastrophic dance, their wreckage briefly igniting before fading into the darkness. Others proposed a more surreal explanation, that it had been an optical illusion, a trick of starlight revealing the limits of our perception. Fomalhaut b's disappearance became more than a puzzle. It was a reminder that in the vast theater of the universe, even the mighty can vanish without a trace. If you have ever stood under a night sky far from city lights, the kind of night where every star is visible and the Milky Way spills across the heavens like spilled sugar, you might understand the pull of such distant worlds. Gazing south in late autumn, your eyes may catch a sharp bluish point of light, brilliant, solitary, steadfast. That is Fomalhaut. Not as famous as Sirius blazing overhead or the stars forming Orion's unmistakable figure, yet quietly extraordinary, holding mysteries invisible to the casual observer. At a distance of 25 light-years, it is a neighbor in cosmic terms, a house at the end of the street of our galaxy, close enough to observe, but far enough to inspire wonder. Light traveling at 186,000 miles per second takes 25 years to reach us from Fomalhaut, so when we see it tonight, we are seeing the star as it was at the dawn of the 21st century. Fomalhaut is the brightest star in the small, understated constellation of Piscis Austrinus, the southern fish, its name derived from the Arabic term for mouth of the fish. Look carefully and you will not see a fish in the sky. Just a lone jewel suspended beneath Aquarius, a solitary sentinel marking a quiet corner of the heavens. But appearances are deceiving. Fomalhaut is far more massive than our Sun, an A-type main-sequence star roughly twice the Sun's diameter and 16 times its luminosity. At an age of approximately 440 million years, it is a young, energetic star, burning hotter, faster, and destined to live a shorter life than our relatively sedate Sun. Its brilliance is not idle decoration. It signals immense energy radiating outward, ultraviolet light, powerful gravitational forces, and a dynamism that shapes everything in its orbit. Surrounding Fomalhaut is a vast, mysterious ring of dust and ice, reminiscent of our solar system's Kuiper belt, but on a far grander scale. Tens of billions of kilometers across, it is a cosmic hula hoop of frozen fragments left over from the star's formative chaos. Here, the remnants of worlds, rocks and ice shattered in ancient collisions, circle silently, an echo of creation and destruction. The ring's sharply defined edges reveal a sculpting hand, gravity's invisible guidance, hinting at the presence of hidden planets shaping the debris. For astronomers, this was an invitation to study not just a star, but the story of a solar system's adolescence, a record of violent artistry in the cosmos. In the early 2000s, a new wave of observation began. Powerful ground-based observatories alongside Hubble peered into the star's surroundings with infrared vision, revealing details invisible to ordinary sight. The dusty ring was crisp and bright, its tilt perfectly aligned for study. It stretched 20 billion kilometers from the star, roughly 140 astronomical units, far beyond Pluto's orbit in our own system. Unlike the irregular debris disks of other stars, this one was pristine, almost as if a blade had carved a perfect circle in the cosmos. Beyond its physical allure, Fomalhaut carries history. Ancient Persian astronomers recognized it as one of the four royal stars, guardians of the heavens. Fomalhaut presided over the southern sky, marking seasonal transitions tied to water and flood myths, standing apart from other stars in a quiet, commanding solitude. Its light, constant and unwavering, seemed to possess a memory, a silent witness to the flow of time. Hubble's gaze eventually revealed the flicker of Fomalhaut B. A tiny point moving against the backdrop of dust, it resisted conventional interpretation. Not glowing like a typical planet, it was something else. Something real. Something massive. The world was hailed as one of the first exoplanets directly imaged, a tangible sight rather than a spectral graph orbiting a star light years from our own. Yet its story was fleeting, a reminder that the universe's generosity is matched by its capriciousness. Fomalhaut itself is a stage, a cosmic theater illuminating the remnants of planetary formation. Its debris ring is a living record, a fossil museum of collisions, comets torn apart, icy bodies shattered mid-orbit. Each fragment drifts through the void, stirred by gravity and radiation, a slow dance across tens of billions of kilometers. Sometimes a collision lights the ring again, a brief flare echoing the violent history of the system. For astronomers, the allure of Fomalhaut lies not only in observation, but in narrative. The star and its ring tell stories of creation and destruction, of worlds almost formed and then undone, of invisible planets shaping the chaos. Each ripple in the dust is a clue, a whisper from a past we can glimpse but never fully know. The search for understanding is ongoing, driven by the beauty and mystery of a system both real and ephemeral, a cosmic paradox of order forged in chaos. Fomalhaut is more than a star. It is a lighthouse in the vast night, a guide pointing to the hidden forces sculpting the universe. Its light carries the memory of violent youth, of the ghosts of worlds that once were, of a planet that flickered and vanished. And as our instruments become more precise, as our gaze penetrates further into its dusty halo, we continue the quest, uncovering secrets written in light, in ice, in the silent motion of fragments circling a star 25 light-years away. In the quiet brilliance of Fomalhaut, astronomers find both challenge and inspiration. A reminder that even the solitary, serene points of light in the sky are monuments to tumult, to history, to forces unseen. In its glow, we see not just a star, but the story of the cosmos itself, forever unfolding, forever fleeting, and forever waiting for those who dare to look closely enough. One of the most influential instruments in the cosmic quest to understand the universe was the Hubble Space Telescope. By the time astronomers turned it toward Fomalhaut, Hubble had already transformed our perception of the farthest reaches of space, revealing distant galaxies, nebulae, and star clusters with a clarity never before achieved. And yet, when it focused on Fomalhaut, it became more than a telescope. It became a precision microscope, examining the intricate and mysterious workings of a star system tens of light-years away. Through its pristine lens, scientists captured the debris disk encircling the star in unprecedented detail, uncovering patterns and structures that seemed deliberate, almost choreographed. Each particle of dust moved in perfect harmony, shaped by unseen forces, like dancers responding to a cosmic conductor. Then came the Space Telescope, an instrument designed to see what visible light could not. Functioning in the infrared spectrum, Spitzer penetrated the dust and glare that obscured the Fomalhaut system. Where Hubble revealed form, Spitzer revealed substance, acting as a celestial detective, illuminating the hidden complexities within the star's surroundings. Together, the two telescopes offered a complementary view. Hubble provided the crisp, visible detail of the debris disk, while Spitzer uncovered the heat signatures and obscured matter that made up its hidden architecture. The Fomalhaut system revealed itself as far more intricate than anyone had imagined, with gaps, clumps, and arcs of dust hinting at gravitational influences that had yet to be fully understood. The astronomical community's excitement reached a fever pitch in 2008 when Hubble unveiled something that transformed speculation into discovery. The once mysterious ring encircling Fomalhaut was more than a swirl of cosmic debris. Hidden within it, astronomers discerned the gravitational signature of a massive body. Evidence pointed to a planet later named Fomalhaut B, its presence inferred from the way the disk shifted and flowed. This was not a hypothetical world. It was a tangible entity whose existence was supported by observational data. Scientists watched as this distant planet emerged from the shadows, the first direct confirmation of a planet shaping its environment in a system beyond our own. The significance of this discovery resonated across the scientific world. Fomalhaut was no longer just a star in the night sky. It had become a portal into the mechanics of planetary formation. Its debris disk was a living laboratory, providing insight into how planets coalesce, migrate, and influence their surroundings. With each new observation, astronomers saw the system not as static, but as dynamic, a narrative of creation unfolding before their eyes. The patterns within the disk offered tantalizing hints of hidden worlds, gravitational sculptures that shaped dust and ice into arcs and gaps, giving rise to questions about the unseen forces at work. Astronomers began to wonder if Fomalhaut might serve as a model for countless other systems too distant or faint to study directly. Could planetary systems elsewhere in the galaxy exhibit similar structures, subtle signatures of planets yet unseen? The debris disk became a cosmic puzzle, each new image revealing both answers and deeper mysteries. Fomalhaut's allure was not simply in its proximity or brightness, but in its ability to challenge assumptions, to show that even the most luminous stars could conceal intricate unseen dramas. The story of Fomalhaut unfolded against the backdrop of a broader revolution in astronomy. For centuries, humans had gazed at the night sky, imagining worlds orbiting distant suns, yet with little means to confirm their existence. The 1990s marked the dawn of exoplanet discovery, beginning with 51 Pegasi b, a giant planet orbiting a star far beyond our solar system. This single discovery opened the door to a flood of new findings, with astronomers confirming dozens, then hundreds of exoplanets in the following decades. Each new world came with unique characteristics, orbits, and atmospheres, expanding the realm of possibility and reshaping our understanding of what planetary systems could be. By the early 2000s, exoplanet hunting had evolved from indirect observation to direct imaging. Telescopes and instruments became sensitive enough to detect the faint glow of planets themselves, reflecting the light of their stars against the infinite black canvas of space. No longer was discovery limited to detecting wobbles or dips in stellar light. Astronomers could now capture actual images, glimpses of alien worlds existing light years away. Fomalhaut and its debris disk became a central target in this new era, a natural laboratory where theories of planetary formation could be tested against reality. Fomalhaut B's fleeting appearance in Hubble images offered a glimpse into the possibilities of the unknown. It represented not only a planet, but the promise of discovery. The thrill of seeing something that had existed unseen for millennia, now rendered visible by the ingenuity of human observation. With each subsequent observation, the system continued to surprise, revealing complexities that challenged predictions, hinting at processes and interactions that scientists were only beginning to grasp. As the 21st century advanced, Fomalhaut became a symbol of humanity's expanding cosmic horizons. It reminded us that the universe, even in seemingly familiar corners, holds secrets waiting for patient eyes and careful study. The debris disk was more than a cloud of dust. It was evidence of dynamic processes, of gravitational choreography, of planets forming and shaping their environments. Each clump, each arc, each shadowed gap was a clue in a story billions of years in the making. Even now, as debates continue over the existence and nature of Fomalhaut B, the system retains its enigmatic power. It embodies the tension between observation and theory, the thrill of discovery balanced by the humility that comes with confronting the unknown. What lies hidden within the dust? What worlds remain unseen? And what secrets could the system yet yield? The star continues to shine, a beacon in the night sky inviting astronomers to look deeper, to imagine more, and to push the boundaries of knowledge further than ever before. Fomalhaut is not merely a star, it is a testament to curiosity, to the human drive to explore, and to the unfolding story of planetary systems across the cosmos. It reminds us that even in the vast silence of space, patterns emerge, planets take shape, and the universe continues to reveal its ancient and intricate rhythms. Every new image captured by our telescopes, every subtle ripple in the data, felt like a trail of breadcrumbs leading us toward answers to questions as old as humanity itself. What is the true nature of the universe? Where, among the billions of stars, might our place in it be defined? Could there be an Earth-like world, one capable of nurturing life as we know it? Or perhaps a planet unlike any we have ever imagined, a celestial body so strange it challenges everything we understand about planetary formation? Could there be a place where life, our life, might one day take root and thrive, distant yet not unreachable? Fomalhaut, with its sharply defined debris ring and the possibility of a planet lurking within, became the emblem of this bold new era in astronomy. The sight of such a pristine, clearly delineated disk of dust and ice around a star relatively close to our own felt almost miraculous, a cosmic gift lying in wait. Out there, in the vast, cold darkness, was a laboratory of planetary creation, a stellar nursery where planets might be gestating, silent and unseen until our instruments were refined enough to detect them. At the center of this swirling disk, many astronomers believed, resided Fomalhaut B, the elusive object that would come to dominate both our curiosity and our imagination. Was it truly a planet, a new world in formation, or merely an optical illusion, a fleeting shadow dancing across the vast emptiness of space? As years passed, the excitement surrounding Fomalhaut grew exponentially. Telescopes were pushed to their limits, adaptive optics refined, imaging technologies perfected, all in the pursuit of glimpsing distant solar systems in unprecedented detail. Each new observation answered one question, but raised 10 more. Were there other hidden worlds lurking within the debris of distant stars, waiting for a patient astronomer to find them? What revelations would the next breakthrough bring? And most tantalizing of all, could there be life beyond our pale blue dot, waiting quietly for us to discover it? The search for exoplanets became more than scientific curiosity. It became a race driven by one of humanity's oldest and most profound questions. Are we alone in the universe? Fomalhaut B was not just another candidate planet. It was a crucial clue, a keyhole through which we might glimpse the broader cosmic tapestry. Yet alongside the thrill of discovery, a shadow of uncertainty persisted. What happens when a planet, seemingly present and observable, disappears from view? Fomalhaut B had captured imaginations worldwide, but its sudden absence posed a riddle that cut to the core of our understanding of planetary systems. How could something so tangible in the data vanish so completely? And more importantly, what might this disappearance reveal about the hidden mechanisms of the cosmos, about the forces that govern formation, motion, and evolution on a scale that dwarfs human comprehension? Humanity has spent centuries gazing at the night sky, striving to unlock the secrets of the stars, and yet, like grains of sand slipping through our fingers, our understanding can vanish in an instant. In the vastness of the universe, how many more answers elude us, hidden just beyond the reach of our telescopes? What truths might dissolve into the darkness before we even have a chance to grasp them? Before we examine the perplexing disappearance of Fomalhaut B, we must return to its miraculous discovery, a moment that rekindled humanity's wonder at the cosmos. In the early years of the 21st century, the night sky served as a silent witness to a subtle yet profound struggle, the vastness of space confronting the boundless curiosity of humankind. For astronomers, the mission extended far beyond simply looking at the stars. It was a quest to answer questions that had echoed through millennia. Are we alone? What worlds exist beyond our own? Could there be a planet just out of reach, waiting silently for the moment it would be unveiled by patient observation and technological ingenuity? By 2004, telescopes and astronomers alike had fixed their attention on Fomalhaut. But it was not the star alone that captured their focus. It was the exquisite debris disk encircling it, a ring of cosmic rubble glinting in the cold starlight. At the heart of this swirling maelstrom, astronomers suspected was a planet unlike any discovered before. Not merely a distant point of light inferred from stellar wobble or dimming, but a planet that could reveal the very mechanisms of planetary birth. This was science fiction brought to the edge of reality. The hunt intensified, a vigil that spanned years, as telescopes remained fixed on the disk, each observation a chance to glimpse the elusive Fomalhaut B. Unlike the majority of exoplanets discovered via indirect methods, this world would not yield its secrets easily. With the relentless advancement of imaging technology, the celestial mystery teased observers with glimpses and hints, sometimes a shadow, sometimes a faint light, always just beyond certainty. Each new dataset both exhilarated and frustrated. Hope flared in the hearts of astronomers when a pattern emerged, only to fade when clarity remained just out of reach. Fragmented glimpses and partial evidence sustained the collective anticipation, fueling a persistent belief that Fomalhaut B was out there, hiding in plain sight. It was not until 2008, when powerful lenses and cutting-edge imaging techniques converged, that the breakthrough arrived. The universe revealed a small, faint point of light embedded within the debris of Fomalhaut's disk. At last, Fomalhaut B emerged from the shadows, a planet no longer an abstract concept, but a tangible presence, glowing faintly against the cold backdrop of space. The discovery sent shockwaves through the scientific community. It was a triumph not only for the team who had captured the image, but for every astronomer whose career had been dedicated to the relentless pursuit of worlds beyond our own. In that moment, the cosmos felt within reach, a door slightly ajar, inviting humanity to peer inside and glimpse the unfolding narrative of planetary creation. But even as the discovery reverberated through observatories and lecture halls alike, hailed as a monumental victory for human curiosity, the questions refused to fade. What exactly was this object, this luminous anomaly appearing like a shy spark against the overwhelming brilliance of its parent star? Was it truly a planet, a fully formed celestial body with its own gravity and orbit, or merely a transient accumulation of debris caught in the cosmic flow of Fomalhaut's sprawling disk? Could it harbor the conditions necessary for life, or was it forever destined to be a silent, frozen wanderer in the outer reaches of its system? The thrill of discovery was inescapable, yet it was tempered by the gnawing uncertainty of the unknown. That faint, glowing speck of light held secrets that even the most sophisticated instruments of the early 21st century could barely begin to decipher. Over the years, astronomers scrutinized the Hubble images with meticulous care. Each pixel was dissected, each curve of light measured, until patterns and anomalies began to emerge. It became increasingly clear that Fomalhaut B defied conventional expectations. Its orbit was irregular, eccentric in a way that challenged the nearly circular paths observed in the planets of our own solar system. Unlike Jupiter or Saturn, tracing smooth, predictable paths, Fomalhaut B seemed to navigate the debris disk with a restless, sweeping trajectory, hinting at a history unlike any familiar planetary formation. Some researchers propose that it had been born at the fringes of its star system, only to migrate inward over millennia, drawn inexorably toward the warmth of its sun. Others posited a more dramatic scenario. Perhaps it was a rogue planet, a wanderer from another system, captured by the gravitational pull of Fomalhaut and forced into a slow cosmic dance. With every subsequent observation, the enigma deepened. Fomalhaut B became more than a point of light. It transformed into a symbol of cosmic mystery, a beacon that provoked debate and speculation across continents and disciplines. To some, it represented a possible new framework for understanding how planets form, challenging decades of assumptions. To others, it remained an unsolved puzzle, a celestial ghost slipping between the cracks of established models. Regardless of interpretation, the fascination was universal. Astronomers around the globe focused their telescopes, the cameras, and calculations on this single object, compelled by the dual forces of curiosity and uncertainty. Yet, always lurking in the background was the unease of impermanence. Would Fomalhaut B, so clearly observed at one moment, remain visible? Or would it vanish as swiftly as it had appeared, leaving only memory and data traces to testify to its existence? The early excitement carried with it a bittersweet tension. What happens when the cosmos allows us a glimpse and then withdraws it? The quest to understand Fomalhaut B became as much about confronting that uncertainty as it was about studying the planet itself. Each new image, each measurement, each subtle shift in brightness and position reminded scientists that space does not yield its secrets easily. It teases, it hides, it flickers just out of reach, demanding patience, persistence, and imagination. The significance of Fomalhaut B was profound. For the first time in human history, a planet beyond our solar system had been seen in visible light. This was not a theoretical inference or a data point derived from the gravitational wobbles of its star, nor a fleeting dimming detected in a transit. It was a pixel of light dancing faintly 25 light-years away, captured directly in our telescopes, a tangible proof of worlds beyond the ones we know. The story of Fomalhaut B is inseparable from the broader arc of astronomical discovery. For millennia, humans gazed upward at stars and constellations, perceiving them as fixed, unchanging points. The notion that these lights might host planets of their own was once poetic speculation, a hypothesis grounded in imagination rather than observation. That changed in 1992 when astronomers detected the first exoplanets orbiting a pulsar, a dead star pulsing like a cosmic metronome. 3 years later, 51 Pegasi b became the first confirmed exoplanet orbiting a sun-like star. Yet even then, it remained invisible, a shadow on charts and graphs. By the early 21st century, hundreds of exoplanets had been catalogued, but none had stepped into the light. None had revealed a face. When NASA released the visible light image of Fomalhaut b, it was more than a technical achievement. It was a transformation of perception. Humanity was no longer limited to abstract detection or mathematical inference. This was a world glimpsed in photons our eyes were naturally attuned to, light that had traveled years to arrive and reflected the same kind of illumination we experience on Earth. The star it orbited, Fomalhaut, is young and radiant, encircled by a vast debris ring that hinted at hidden sculptors, unseen forces shaping the system from within. Observers trained their lenses with painstaking care. In 2004, a faint dot appeared. By 2006, its motion was perceptible. By 2008, the path was undeniable. Fomalhaut b moved with purpose, tracing an orbit that whispered of a coherent mass behind the light. Yet even in triumph, doubts persisted. Its brightness was puzzling, too intense for the estimated mass, hinting at possibilities such as a surrounding ring system or a cluster of icy fragments. Thermal readings failed to match expectations, adding to the intrigue. Fomalhaut b was confirmed as a planet, yet one that defied conventional understanding. Over time, with sharper instruments and more precise measurements, new questions emerged. Its orbit remained eccentric, its luminosity inconsistent. Some speculated that what had been observed was not a planet at all, but a transient dust cloud, briefly ignited and then fading, a cosmic illusion teasing the limits of perception. Despite these uncertainties, the fascination with Fomalhaut b only grew. It was a symbol of what could be seen, what could be imagined, and what might still elude understanding. Each image captured by the Hubble Space Telescope, each glimmer within the icy ring of debris, reminded astronomers and the public alike that the universe is full of hidden worlds, waiting for patient eyes and curious minds to notice. Whether planet, collision cloud, or something in between, Fomalhaut b shimmers in the collective memory of discovery, a testament to humanity's drive to reach beyond our immediate grasp and touch the vast unknown. This wasn't merely a pinpoint on a chart. It was a presence, a figure among the billions, the first exoplanet ever captured in visible light, staring back at us across the vast gulf of space. But almost immediately, something felt wrong. Its radiance was excessive, blindingly unnatural, like a single candle blazing in the black silence of a cave, defying reason and expectation. Gas giants, the class of planets this object, Fomalhaut b, if it truly was a planet, would belong to, are not meant to shine like this. They are frigid, especially at the yawning distances they orbit from their stars. Their natural glow is weak, mostly confined to the infrared, the faint warmth of ancient formations seeping outward like the dying embers of a long extinguished fire. Visible light, by contrast, comes from reflection, the delicate dance of sunlight rebounding off clouds of gas, ice, or dust. Yet Fomalhaut b radiated far too brightly. Its brilliance was alien, a celestial anomaly, like witnessing the moon outshine the sun itself. Some suggested it might possess an immense ring system or a halo of dust, scattering starlight like fog in a street lamp, creating an artificial brilliance. Yet, even the most generous calculations strained to account for its luminance. It was as if a dim flashlight suddenly became a spotlight, a light of impossible intensity. Something else, something entirely unknown, was at work. The peculiarities multiplied. Fomalhaut b was cold, silent, insubstantial, like a specter glimpsed from the corner of your eye. Its orbit was irregular, its appearance transient. The light flickered, dimmed, shifted, and blurred until one day it vanished completely. Real planets do not disappear. Back in 2008, none of this was known. All astronomers had at first was a moment of discovery, a single gleaming dot that could have been a new member of our cosmic family. It was a message, an enigma. Its visibility alone was not proof of planetary reality. It was a crack in the illusion. Fomalhaut B's unusual brightness, coupled with its inexplicable behavior, was the first whisper of doubt. In the cosmos, heat is truth, the lingering echo of a world's formation, the ember in the darkness that reveals presence even when light is obscured by distance, dust, or a star's glare. Infrared is our lantern in the void. When scientists trained that lantern on Fomalhaut B, they found nothing. After the initial thrill of witnessing this supposed planet in visible light, astronomers naturally turned to other tools, other wavelengths, seeking warmth, substance, confirmation. NASA's Spitzer Space Telescope, launched in 2003, had become a trusted sentinel, revealing the heat of distant worlds even when they were invisible to Hubble's optical eye. Young gas giants, like the one Fomalhaut B was expected to be, should radiate heat like coals beneath a blanket. Even at an estimated age of 400 million years, the residual warmth should persist. Yet Spitzer detected nothing. No heat signature, no infrared glow, no trace of a living, breathing planet. It was as if Fomalhaut B existed only as a trick of light. This absence was not a minor curiosity. It was a profound contradiction, a rupture in the narrative. A planet that shines in visible light yet remains cold in infrared is a paradox. A fire without burn, thunder without lightning. Some hypothesized dust clouds scattering starlight might account for the illusion. Others imagined a planet that had cooled unusually fast, a singular anomaly. Yet even these explanations faltered in the face of Spitzer's silence. The simplest haunting truth loomed: maybe this object was never a planet at all. To appreciate the strangeness, consider Spitzer's track record. It had captured the heat of far more distant and cooler exoplanets, traced thermal signatures of close-orbiting hot Jupiters, and glimpsed even smaller, fainter bodies. Its failure to detect warmth from Fomalhaut B was not error, it was revelation. The visible light that captivated us was devoid of substance, a phantom glow without mass or internal heat. The initial euphoria of discovery, the media frenzy, the simulations and classroom animations began to flicker under the absence of infrared confirmation. The astronomy community grew divided. Some held on to planetary status, citing orbit, brightness, and possible ring-induced distortions. Others, increasingly vocal, pointed to mounting inconsistencies. Fomalhaut B had become an apparition, a fleeting spectacle. The question shifted from what kind of planet is this to what kind of trick of light are we witnessing? Was it the aftermath of a collision, two icy bodies smashing together near Fomalhaut's debris ring, sending plumes of reflective dust into transient brilliance? A scattering of comet-like fragments, a temporary chaos of cosmic matter? The ephemeral light could explain brightness, form, and absence of heat, even disappearance. If true, what was captured was not a world in formation, but a world in unmaking. Astronomy is full of paradoxes. Sometimes we seek for decades and find nothing. Other times we find something so convincing we ache to believe it. The lack of infrared from Fomalhaut B shattered certainty, transforming triumph into mystery, discovery into a novel written across light years in fading glimmers. Each new observation, each theory, came with a quiet, nagging question. What else are we seeing wrong? If the first planet ever glimpsed with our own eyes was never a planet at all, then what truly awaits in the star-speckled void? When images emerged in 2008, the response was electric. Hubble had seemingly plucked a planet from the glare of Fomalhaut, a visible exoplanet at last. Unlike the ghostly presences inferred from gravitational wobbles or transits, this was tangible, poetic, almost human in its immediacy. The media heralded a new age: planet caught on camera, alien world photographed. Simulations, animations, and flyby renderings celebrated its stormy clouded presence. In classrooms and planetariums, Fomalhaut B became a symbol of ingenuity, a triumph of observation over distance. Yet within the scientific community, unease grew. For Paul Callis and the Discovery team, it was a crowning achievement, the payoff of painstaking years. But others ran the numbers and found inconsistencies. A planet orbiting some 100 times Earth's distance from its star, more than 3 times Pluto's distance from the Sun, should not shine this bright invisible light while remaining undetectable in infrared. Reality, it seemed, was far stranger than the photograph suggested. A gas giant, fresh from its cosmic cradle, should still radiate warmth, its internal fires leaking faintly into the cold void, glowing in the infrared like a whispered secret of its birth. It should be luminous, steadfast, a silent guardian circling its star. Yet Spitzer's gaze returned empty, nothing but darkness where there should have been heat. That absence was disquieting. Scientific meetings shifted from lively exchanges to subdued tension. Papers circulated with cautious excitement, rebuttals followed with equal fervor. The planet's orbit, meticulously charted, defied expectation. It was too eccentric, too stretched, a celestial path that seemed almost intentional in its anomaly. Its brightness was inconsistent, fluctuating from year to year, refusing the predictable constancy expected of planets. Some years it shone brighter than imagined, other years it dimmed as if teasing astronomers, refusing to conform. In the cold, precise universe of planetary mechanics, Fomalhaut b flickered like a fragile candle, ephemeral and unpredictable. New theories began to emerge. Perhaps this wasn't a planet at all. Perhaps Hubble had captured a transient phenomenon, a vast cloud of dust, debris from a violent collision of icy worlds, a fractured ring system, or a swarm of comet-like fragments reflecting light as they disintegrated. In 2012, a meticulous team revisited the original data and argued precisely that. Hubble's celebrated image, they claimed, did not show a planet, but the aftermath of a cataclysm, a cloud masquerading as a world. The debate simmered quietly, refusing to boil over. Official catalogs still listed it as a planet, and the media, enchanted by the imagery, kept calling it one. For many, the photograph itself was convincing enough, a visual proof that needed no mathematical validation. But science does not rest on hope or aesthetics. It sharpens its instruments, observes patiently, and listens to the subtle messages of the universe. As years passed and new data accumulated, the balance began to tip. Between 2004 and 2014, astronomers maintained a steady vigil. Fomalhaut b's light began to fade, subtly at first, then unmistakably. By 2014, it was nearly gone. There was no gradual dimming, no elegant exit, only absence. The once celebrated dot had vanished. The firefly had been extinguished, and with it, the last vestiges of unquestioned planetary belief began to crumble. The scientific community, tempered by patience and the weight of evidence, slowly reframed the narrative. In 2020, NASA officially reclassified Fomalhaut b. It was no longer a planet, but a dust cloud born of a violent collision, a fragment of cosmic destruction masquerading as creation. Paul Callis, the astronomer who had once heralded the discovery of the first directly imaged exoplanet, now stood witness to a different truth. What had been celebrated was not a creation, but a scar, a trace of destruction frozen in time. Yet, the original image retains its power. Astronomers still study it not as a mistake, but as a meditation on the fragility of discovery, the ease with which light can mislead. Fomalhaut b became more than a failed planet. It became a lesson in humility, a reminder of how little we truly understand about the cosmic dance of light, matter, and distance. In chasing worlds, we sometimes capture only shadows. Fomalhaut b was a ghost, a mirage, a violent scar drifting along the edges of a star system still largely unexplored. Perhaps the more profound question is not what it was, but what else lies hidden in the faint glimmers of the universe, waiting to deceive, to vanish, to challenge the patience of those who seek it. The euphoria of discovery in astronomy is often fleeting, dissipating faster than the data can cool. Headlines fade, press releases are archived, and the relentless scrutiny of science begins. Fomalhaut b never conformed. Unlike most exoplanets, cloaked in the dark velvet of their systems and detectable only through subtle gravitational tugs or eclipses, Fomalhaut b gleamed conspicuously in Hubble's optical range, like a single dewdrop catching the sunrise. That brilliance marked the first fissure in understanding. Its motion did not obey expectation. Planetary orbits are predictable, like dancers tracing ellipses with precision, yet Fomalhaut b drifted along a path too eccentric, too elongated to be comfortable. It swooped around its star not as a faithful companion, but as a stranger moving with deliberate peculiarity. Was it bound to Fomalhaut at all, or merely a cosmic tourist passing through? Even the surrounding icy debris ring, a sculpted halo of shattered rock and ice, complicated matters. The Discovery team initially believed Fomalhaut b acted as the ring's shepherd, its gravity corralling debris. But the object's position did not support this. It skimmed the edge like a skater on the perimeter, influencing indirectly, mysteriously, perhaps not at all. Alternative theories proliferated. Maybe it was a fragment of some ancient collision, perhaps a swarm of hundreds of icy bodies blended from Earth's distant view into a single point of light. Was it a thing or a transient happening, a moment of cosmic theater masquerading as a planet? The Discovery team defended their claim for years. Science rarely retracts its proclamations quickly. Fomalhaut B was alluring, enigmatic, demanding patience, demanding humility. Yet evidence slowly slipped away from the planetary model. Planets endure. They emit heat, maintain predictable orbits, influence their systems. Fomalhaut B did none of these. Then, as if the universe decided to punctuate the lesson, it disappeared. The signs had been there all along, subtle as creaks in a grand house hinting at structural weakness. Its fading was as telling as its discovery, a stark reminder that in the vast theater of space, what we see may be fleeting, deceptive, or entirely illusory. Fomalhaut B transformed from a celestial prize into a symbol of caution, of wonder tempered by patience, a whisper of humility echoing through the corridors of astronomical history. Diving deeper into the slow disappearance of Fomalhaut B, a phenomenon that initially caught astronomers entirely off guard, the story begins with what seemed like nothing more than a fleeting anomaly. At first, it was a subtle flicker, a barely perceptible dip in brightness, so slight that it teetered on the edge of measurement error, a minor irregularity easily dismissed as instrumental noise, an algorithmic hiccup, or a speck of cosmic dust drifting between our telescopes and the distant unknown. Yet this was no one-off glitch. It was the first faint whisper of an unraveling that would grow steadily, inexorably, as Fomalhaut B, once celebrated as the first exoplanet captured in direct imaging, began to fade from view. Its decline marked not only the dimming of a distant world, but the gradual dissolution of a story that had seemed as luminous and certain as the planet itself. Back in 2004, Fomalhaut B shone through the Hubble Space Telescope like a solitary lighthouse perched on the edge of a cosmic ocean. Bright, stubborn, and remarkably distinct in optical wavelengths, it stood out as an anomaly in a sky dominated by unseen worlds. Astronomers marveled at it, fascinated by its defiance of the expectations surrounding exoplanets. The excitement only deepened with follow-up observations in 2006, 2010, and 2012, each pass of the telescope layering more data onto the narrative. But as the years passed, the threads of that narrative began to thin. Detailed image analysis revealed something subtle but undeniable. The planet's brightness was not constant. It was waning, slowly, quietly, almost imperceptibly at first, but by 2014, the decline could no longer be ignored. Fomalhaut B was dimming like a dying ember, not flickering erratically as a star might under the interference of cosmic dust, but fading steadily, almost mournfully, as though the light itself were slipping from existence. In astrophysics, brightness is more than a measure of visual appeal. It is a window into a world's mass, composition, and energy output. When a planet begins to lose brightness, it sends ripples of confusion through the scientific community. Planets do not vanish. They reflect light in predictable ways, their orbits serving as anchors, their visibility shifting only subtly with perspective and distance. Yet, Fomalhaut B defied these expectations, leaving scientists to ask unsettling questions. One theory captured the imagination and unease of the community. It suggested that Fomalhaut B had never been a planet at all. Perhaps it had always been a cloud, a diffuse swirl of dust and ice that over time expanded and scattered until it dimmed and disappeared. In this view, the disappearance was not a vanishing act, but a slow disintegration, a celestial fade into nothingness. Another, even more surreal possibility was that the object had been a transient visitor, an interstellar fragment reflecting the star's light as it passed through the system. This would explain its unusual orbit, the lack of heat signatures, and the gradual dimming, but it also raised deeper questions about timing, probability, and the fragility of human understanding. For others, the most haunting explanation was the most poetic. Fomalhaut B was a planet, but one caught in its final catastrophic moments. Perhaps it had been torn apart by gravitational forces or obliterated in a violent collision with another object. Its core destroyed, its atmosphere stripped away, its remnants scattered across space, leaving only the faint glow of dust and ice to reach our telescopes. The first image was not of a world itself, but of its echo, a planetary funeral shroud briefly illuminated by the parent star before fading into silence. By 2020, the mystery reached a kind of resolution, though one steeped in melancholy. Updated analyses of Hubble data revealed that the object had vanished entirely, leaving no trace, no hidden fragment, nothing but memory. What had once been heralded as a groundbreaking discovery was recast as a mirage, a fleeting alignment of dust, light, and timing that masqueraded as a planet. Astronomy, ever a discipline of patience and long-term observation, reminded us through Fomalhaut B that the universe often speaks in riddles. Reaching across the void, we had hoped to grasp a distant world, yet all that remained in our hands was starlight and dust. Perhaps the most puzzling aspect of Fomalhaut B was not just its disappearance, but the peculiarities of its orbit. When first observed, the speck of light seemed to follow the rules, a small companion tracing a path just outside the icy debris disk surrounding its parent star, a bright A-type star 25 light-years away in the constellation Pisces Austrinus. Initially, it appeared familiar, planetary, predictable. Yet, as years of observations accumulated, the object's motion began to diverge from expectations. Planets are bound by the precise rhythms dictated by gravity, following ellipses in a cosmic choreography stretching back billions of years. Fomalhaut B, however, moved out of sync, veering away from the debris belt rather than tracing a stable orbit within it. By 2013, alarm rippled through the astronomical community. Even early proponents of the discovery, such as Paul Callis, began expressing doubts. Fomalhaut B's trajectory defied the norms of a long-term planetary orbit. Rather than cruising through the disk like Neptune does in our solar system, it cut across the debris as if unaware of the invisible forces governing its neighbors. In celestial mechanics, such behavior is a red flag. A planet massive enough to move along that path should have gravitationally disrupted the disk, scattering material and leaving a chaotic aftermath. Yet the debris ring remained largely intact, a testament to the impossibility of Fomalhaut B as a conventional planet. The slow fading, the erratic orbit, the eventual disappearance, all of it paints a portrait of a cosmos that is both beautiful and merciless, a universe where even the most brilliant discoveries can dissolve into mystery. Fomalhaut B was never merely a distant exoplanet. It became a lesson in humility, a reminder that in observing the heavens, certainty is fleeting, and every light may hide a story more strange and fragile than we ever imagined. But the disk remained untouched, a flawless loop of ice and cosmic dust, circulating in perfect harmony, indifferent to the gravitational pull of any passing celestial heavyweight. So if the orbit of the star's planet didn't disrupt the ring, how could the object even qualify as a planet? For some astronomers, the trajectory suggested a story far more ephemeral. Perhaps Fomalhaut B was not orbiting at all. Perhaps it was merely passing through, a transient visitor in the stellar neighborhood. One theory proposed that a smaller fragment, maybe debris from a collision, had been briefly illuminated by the star, catching a fleeting glow before being cast outward like a tiny ember from a cosmic fire. Or perhaps it had once been a planet, a body shattered by a cataclysm long ago, hurled from its original orbit, left to wander across the void like a lonely interstellar nomad. Still, other researchers lean toward an even stranger explanation. What if the motion we saw wasn't motion at all, but an illusion? A trick of scattered light, an artifact of geometry interacting with dust, a ghostly echo masquerading as a tangible object. When you peer deep enough into space, even the concept of direction can become suspect. The most disturbing aspect of all was the apparent trajectory. Fomalhaut B seemed to be moving straight out of the system. Extend its path forward, and it did not curve back toward the star. It pointed outward, beyond the debris belt, beyond the outer reaches of the star's gravitational influence. On a cosmic timescale, it appeared destined to leave Fomalhaut entirely. Planets do not behave this way. Planets are tethered to their stars. Fomalhaut B was different. This strange orbital behavior challenged every assumption astronomers had built since the early days of its discovery. It raised questions not only about the object itself, but about the very process of observation. Had humanity been so eager to confirm the presence of a planet that we overlooked subtle signs of its oddity? Sometimes the universe doesn't hand over puzzles in neat, solvable packages. Sometimes it presents illusions, carefully wrapped in enough familiarity to mislead the observer. Humans, eager to interpret patterns, often fill in the blanks with expectation rather than reality. As scientists traced Fomalhaut B's path over time, each model unraveled. No stable orbit could reconcile the data. No combination of mass and brightness explained the observed behavior. What emerged was a portrait of contradiction, an object bright enough to be detected, yet without the thermal signature expected of a planet. Massive enough to leave a gravitational mark, yet leaving no imprint on its surroundings, moving with apparent intent, yet along a path that defied celestial mechanics. It was as if Fomalhaut B had authored its own laws, a rogue in a cosmos governed by rules. Some began to whisper that perhaps humanity had been chasing a shadow all along. As Fomalhaut B drifted farther from its star and from conventional definitions, it left more than questions. One of the most pressing was how it had simply vanished. For years, Fomalhaut B had hovered just beyond certainty, too faint to pin down with confidence, too luminous to ignore, an echo masquerading as a planet, a ghost in orbit, and then, without warning, it disappeared. Not obscured, not hidden, it ceased to exist. By 2020, the revelation was quietly documented in the Proceedings of the National Academy of Sciences. Researchers led by Andres Gaspar and George Riek at the University of Arizona revisited archival Hubble Space Telescope data, meticulously piecing together more than a decade of observations. What they found was startling. The exoplanet once celebrated as a triumph of direct imaging had faded entirely. Like a lighthouse swallowed by fog, it dimmed, flickered, and vanished. This was no ordinary disappearance. Planets do not simply wink out of reality. They may hide behind glare or slip behind dust belts, but they do not erase themselves. By 2014, Fomalhaut B was already dimming. By 2020, it was undetectable across all previously observed spectra. Astronomers combed the data repeatedly, subtracting noise, filtering anomalies, replaying observations, and yet the conclusion was undeniable. The object that had once illuminated the edges of our celestial maps was no longer there. The researchers concluded that it was not a planet in any conventional sense. It lacked the heat signature all planets radiate, even frigid giants in distant orbits. Fomalhaut B's light came not from internal warmth, but from reflection, momentary sunlight caught by dust before fading into shadow. They proposed a radical hypothesis. Fomalhaut B was not a planet, but a transient cloud of dust. Debris from a collision between icy bodies in the outer system lay tiny shards propelled at immense speed, forming a luminous cloud temporarily illuminated by the star, gradually dispersing into nothingness. Imagine two ancient frozen titans colliding in the outer reaches of a system, their fragments scattering at thousands of kilometers per hour. For a time, the debris glowed brightly, giving the impression of a coherent object, a planet. But it was merely the afterglow of violence, a cosmic wound still bleeding light. The implications were profound. A celestial body could appear solid, bright, and definable for over a decade, only to vanish without a trace. Astronomers who build worlds from photons traveling for decades or even millennia rely on the assumption that what they observe is real. Fomalhaut B shattered that assumption. It was not an error, nor a hoax. It was a mirage, a phenomenon fleeting enough to fool even the most careful observers. Even more intriguing, its fading had been predicted. Researchers in 2012 noticed a decline in brightness, inexplicable at the time. In hindsight, it was the first hint that the object was not a planet, but a dispersing cloud of debris. By 2020, it had grown too faint for even Hubble to detect. The story had ended, but its consequences were only beginning. How many other supposed planets might be illusions? How often does the cosmos allow us to believe in phantoms simply because we lack the means to see through them? The ghost left behind nothing but mystery. Fomalhaut B had glimmered once in the starlight, an anomaly we thought we understood. Then it vanished, leaving no debris, no ring, no trace of catastrophe. When massive celestial bodies disappear, some evidence is expected, a scattering of dust, a debris field, a signature of destruction. But in this case, there was nothing. Fomalhaut B did not fade like a ship slipping into fog. There were no comet-like trails, no ring formation, no leftover fragments. It was as if a page had been torn from the cosmic narrative, leaving no record that it ever existed. Early hypotheses suggested a cloud of icy debris surrounded it, but nothing endured. A planet, a cloud, a reflection of violent history, or simply a phantom. The lines blurred, leaving astronomers and observers with one unyielding reality. The sky can lie, and even a decade of certainty can dissolve in an instant. But even that theory stumbled under scrutiny, because if it had held any weight, we would have witnessed undeniable evidence. Debris swirling in chaotic dances, forming rings around its star, scattering across the orbit like cosmic breadcrumbs. Yet the universe offered nothing. Not a single fragment, not a trace to mark that something colossal had ever existed in that celestial expanse. And that absence is the first fissure in the story. Without debris, without even the faintest whisper of destruction, how could an object as massive as Fomalhaut B simply vanish? A body of that magnitude, whether it was a planet or some other celestial formation, should have left behind echoes, a residue, a cosmic memory that would linger in the void. Instead, there was only silence, a haunting, unbroken silence that mocked every expectation, leaving scientists grasping at the thinnest threads of theory. Was it a mirage, an ephemeral anomaly that flickered into existence only to vanish without warning? Or perhaps the light and data that led to its discovery had been warped, bent by unseen cosmic forces, making something entirely illusory appear real? Some speculated it might not have been a planet at all, but an enigmatic entity that mimicked planetary behavior while eluding the laws that govern more conventional bodies. Could it have been a rogue cloud of dust? Possibly. Yet even a cloud would leave signs, faint rings of particles scattered across the orbit, remnants that should persist long after the source light faded. But nothing persisted. The universe remained obstinately silent, offering no simple resolution. As the years stretched on, more researchers arrived at the same unnerving conclusion. The object once celebrated as a groundbreaking discovery had evaporated from view, leaving behind no evidence of cataclysm, no scattered remnants, nothing at all. And yet, in that vacuum of proof, nothing was definitively confirmed. Each failed observation, every fruitless attempt to detect Fomalhaut B, only amplified the questions. Could an entity of such immense scale truly vanish into the cosmos without a trace? Where could its mass have gone if not strewn across the heavens or destroyed in a titanic event? The universe, relentless in its processes, rarely allows such vanishing acts to go unnoticed. Stars ignite and scatter light across incomprehensible distances. Planets emerge, leaving residual matter in their wake. Dust condenses into nebulae, shaping new systems in chaos and turbulence. Yet here, in this particular corner of space, Fomalhaut B left nothing. Not a trace, not a whisper, not even a shadow of its former presence. This is a puzzle that forces us to question everything we thought we knew about the cosmos. It compels reflection on the nature of reality itself. What do we define as real when the universe can stage illusions so convincingly that even our most advanced instruments fail to differentiate them from truth? Perhaps Fomalhaut B never truly disappeared, but merely slipped into a phase of existence beyond our perception, a realm of physics and phenomena we are not yet equipped to understand. The question is not merely what happened to it, but what its disappearance implies about the limits of human comprehension. Could this void, this absence of evidence, hint at structures or realities lurking just out of reach, waiting for observation methods we have yet to invent? Could there be other Fomalhaut Bs scattered through the galaxy, ghostly presences masked by distance, or our instruments' inadequacies, glimpsed only in fleeting hints of light and matter? As the story unfolds, it becomes increasingly difficult to separate fact from speculation. The line blurs, and in that uncertainty, a web of possible explanations forms, each more perplexing than the last. The object that once seemed concrete, a planet with measurable dimensions and predictable behavior, begins to dissolve in the minds of astronomers. First came the whispers of doubt. Perhaps it was a data anomaly, a fleeting misread of a telescope. Space is vast, complex, and filled with interference. Instruments, despite their sophistication, have limits. Even the Hubble Space Telescope, with its unparalleled clarity, can be deceived by cosmic noise, and a momentary glitch could conjure the illusion of an entire planet. Perhaps Fomalhaut B never disappeared because it never truly existed in a form we could reliably observe. But that notion felt unsatisfyingly neat. The missing planet, or whatever it had been, was too vivid, too substantial, to be dismissed as a mere technical hiccup. And so, speculation evolved into deeper inquiry. Perhaps Fomalhaut b was not a single entity, but a composite, a transient convergence of phenomena, a dust cloud interacting with the scattered remnants of a prior cosmic collision, forming for a brief instant what appeared to be a planet. Some even posited it might have been an optical coincidence, a background object, a distant celestial body seen through an unlikely alignment, a mirage created by perspective alone. Yet none of these explanations accounted for the total lack of residual evidence. No faint rings, no scattered dust, no lingering glow. The mystery deepened with each new hypothesis, pulling astronomers further from certainty. The more the scientific community probed, the more unsettling the implications became. Our understanding is inherently limited by the tools we possess. We see only what our instruments allow, comprehend only what our cognition can process. What if Fomalhaut b existed in a dimension beyond those capacities, a reality just beyond our reach? Perhaps its disappearance is not merely a puzzle of astrophysics, but a mirror reflecting the boundaries of human understanding. Maybe the answers lie in realms we cannot yet access, waiting to expand our perception of existence. Every theory carries its own staggering implications. Collisions in space are inevitable. Stars merge, black holes consume, comets fragment, scattering debris like cosmic confetti. Once Fomalhaut b's existence was questioned, myriad explanations emerged. One particularly compelling idea proposed it was not a new planet at all, but the remnants of an older structure, shattered by a cataclysmic collision. In this theory, what appeared as a singular planetary body was merely the aftermath of two immense icy objects colliding at the fringes of a system, leaving a dispersed cloud of debris that briefly coalesced into a recognizable form, only to disperse again, leaving nothing but a whisper of its former grandeur. The universe remains silent on the matter, but the enigma of Fomalhaut b persists, a cosmic puzzle that challenges our assumptions, our instruments, and our very definitions of reality. But how can we truly grasp the enormity of such a celestial event? Picture, if you will, two titanic icy worlds, ancient relics of the primordial dust and gas that once swirled through the infant solar system, hurtling toward each other across the void. Drawn inexorably by gravity, their fates entwined, they collide in an instant of cosmic violence. The impact is beyond comprehension. Matter shatters and compresses, fragments scattering like shards of a colossal cosmic mirror. From this unimaginable destruction, a new form of chaos emerges, not a planet, not a solid body, but a luminous cloud of dust and gas suspended in the cold darkness by the very gravity that tore it apart. This phenomenon might explain why Fomalhaut b never fit neatly into our understanding of planets. It lacked a solid surface, had no distinguishable atmosphere, and existed only as the faint, flickering remnants of an ancient collision, drifting aimlessly in orbit around its parent star. The theory carries a profound, almost tragic beauty, the bittersweet duality of an ending and a beginning. The destruction of a planet, if indeed that is what occurred, does not leave emptiness. It produces a fleeting brilliance, a transient spectacle of light in the endless void. For a brief moment, the detritus of the collision shone brightly enough to be captured by the eyes of astronomers, a ghostly, haunting glimmer against the backdrop of space. But as with all things in the cosmos, it was ephemeral. Over time, the dust dispersed, drifting ever farther, fading from view until it became imperceptible to our instruments. The memory of a world that might have once been real slowly transformed into nothing more than a faint echo in the universe's vast expanse. Contemplating this theory brings with it an emotional resonance, a reflection of life's fleeting fragility. Fomalhaut b, once a beacon of promise, existed only briefly before succumbing to destruction. Yet that destruction was not meaningless. Its icy remnants and scattered debris have provided a rare window into the mechanics of planetary formation, revealing that even in chaos, there is both beauty and order. The dispersed dust may have vanished from sight, but it offered humanity a chance to witness the raw, violent processes that shape the grand tapestry of the cosmos. Consider the implications. If Fomalhaut b arose from a cataclysmic collision, it serves as a reminder that the universe is not static. Everything is in motion. Planets, stars, even the objects we take for granted as immutable are caught in an unending cycle of creation and destruction. The violent birth of Fomalhaut B was one moment among infinite others, a brief intersection of forces where something new emerged from the remnants of the old. And what became of the debris? After the initial explosion and the settling of dust, did these fragments coalesce into new celestial bodies? Did they form moons, planets, or even nascent stars? Or did they drift endlessly, lost to the void? Some scientists speculate that the scattered remnants of Fomalhaut B might hold vital clues to the formation of planetary systems. Others ponder the fleeting nature of discovery itself, the idea that humanity is perpetually on the brink of witnessing something that will vanish almost as soon as it appears. The real question may not be whether Fomalhaut B existed as a planet, but whether we can ever truly comprehend the ephemeral, chaotic episodes that define the universe. In our search for understanding, do the wonders we uncover slip through our grasp like stardust forever beyond our hold? Is the cosmos a place of transient beauty, where even a planet exists only for a brief instant, caught between formation and dissolution? The collision theory is more than a scientific hypothesis. It is a lens through which to view the extraordinary processes at work in the universe. Collisions in space are nothing like accidents on Earth. There are no screeching brakes or shattering glass, only the silent, devastating convergence of colossal bodies at unimaginable velocities. Yet these silent cataclysms ripple through space-time itself, forging stars, shaping planets, and flinging debris across light years. Some of the most spectacular and destructive moments in the cosmos arise from these encounters, and even worlds thought permanent can vanish in an instant, much like Fomalhaut B. Consider the scale of such events. When celestial bodies collide, be they asteroids, comets, or protoplanets, they do so at speeds measured in tens of kilometers per second. The collision is not a gentle nudge. It is a violent release of energy beyond ordinary comprehension. Imagine two trains hurtling toward each other, but instead of steel and passengers, it is ice, rock, and gas that crashes together. The energy unleashed is monumental, sending clouds of debris outward in all directions, glowing faintly as they drift from the point of impact. Unlike terrestrial collisions, however, these cosmic fragments do not settle neatly. They form clouds, ephemeral and ghostly, drifting, dissipating, vanishing from view over time. From such collisions arise complex and delicate structures, glowing rings, belts of debris, swirling clouds of gas. Their beauty is matched only by their impermanence. Yet even in their fleeting existence, these formations allow us to glimpse the mechanics of planetary evolution. Observing such phenomena requires sophisticated instruments. Telescopes like the Hubble Space Telescope and the upgraded James Webb Space Telescope can detect the faint glow of distant dust clouds, the aftermath of collisions, and the intricate rings formed by scattered debris. These observations transform distant, violent events into something perceptible, allowing humanity to trace the echoes of cosmic destruction and creation across the universe. In the end, Fomalhaut B is a story not just of a lost planet, but of the delicate, fleeting moments that shape all things in the universe. It is a reminder that even in destruction, there is creation. Even in chaos, there is structure. It is a ghost, a memory, a brilliant yet transient testament to the ceaseless dance of celestial bodies, where every end heralds a new beginning. And every fleeting flash of light tells the story of the cosmos itself. However, the nature of these cosmic collisions is profoundly elusive, their fleeting traces slipping through even the most vigilant telescopes. In the vast emptiness of space, debris often shines too faintly or disappears too rapidly, leaving astronomers with only brief glimpses before the remnants vanish entirely. The light these cataclysmic encounters emit exists in a delicate, ephemeral window, a fleeting signature captured only as the violent release of energy still lingers. Much like Fomalhaut B, which appeared briefly and then vanished like a candle snuffed in the void, the aftermath of such collisions often leaves behind only whispers of their occurrence. The energy radiated during these cosmic events is detectable in specific wavelengths, such as infrared or ultraviolet, but these signals are inherently transient. Over time, the brilliance fades, and the universe continues, seemingly untouched, as though the cataclysm never occurred. Yet, embedded within this fleeting destruction is the paradoxical power of creation. Collisions do not always signify absolute endings. They can also seed new beginnings. Out of chaos, new stars may ignite, planets may coalesce from dust and rock, or ethereal clouds of gas may drift away, carrying the memory of violence that birthed them. Consider the asteroid belt within our own solar system, a sprawling field of rocky remnants that never coalesced into a planet, held in check by Jupiter's immense gravity. Even in planetary collisions, this cosmic aftermath manifests as an intricate and haunting beauty. Particles scatter, telling stories of worlds torn apart, sometimes forming rings like Saturn's, other times dispersing into invisibility, much like Fomalhaut b. The universe possesses an uncanny ability to conceal its scars. What appears to be a solid celestial body may in fact be an ephemeral specter, a momentary assemblage of debris fading into the cosmic backdrop. Fomalhaut b exemplifies this delicate impermanence. Initially thought to be a planet, its fleeting light and unusual orbital behavior defied conventional planetary models. Observations suggested instability, a slow disappearance that left astronomers questioning their assumptions. To unravel the mystery, they turned to simulations, constructing virtual landscapes of stars governed by the laws of motion, gravity, and thermodynamics. These models recreated the violent dynamics of the cosmos, exploring the possibility that Fomalhaut b was not a stable planet, but the debris of a colossal collision. The simulations revealed a scenario of profound devastation. Two icy bodies colliding at immense speeds, their remnants forming a transient cloud of dust and gas. This ephemeral formation matched the observations perfectly. What had been mistaken for a planet was, in truth, a dissipating cloud, scattering in all directions, fading into nothingness. Fomalhaut b was a ghostly echo, the final throes of a world that once existed, now reduced to stardust, adrift in the void. This revelation reshaped our understanding of the cosmos. The universe, once assumed to offer stable, tangible objects, revealed itself as a realm where appearances are fleeting and even seemingly solid worlds can be illusions. Fomalhaut b's story illustrates the delicate balance between destruction and creation, a cosmic dance where catastrophe seeds brief flashes of beauty and innovation. The object was never a planet to explore. It was a transient moment, a radiant memory born from cosmic violence. The tale of Fomalhaut b underscores the fragility of the universe. From its violent origin to its ephemeral illumination and ultimate disappearance, it challenges assumptions about permanence and reality. It compels us to ask how much of what we see is genuine and how much is a fleeting illusion shaped by the unseen forces of collision and chaos. The story begins in devastation, peaks in a fleeting radiance, and concludes with quiet absence, leaving only the faint echoes of a celestial life that once was, a reminder of the universe's transient beauty and its ceaseless cycle of creation and destruction. But the true story of Fomalhaut b is far more than a tale of a vanished world. To fully grasp what unfolded, we must first transport ourselves into the cold, silent void of its cosmic neighborhood. Picture two massive icy bodies, relics of a long-lost planet, hurtling toward one another at speeds beyond human imagination. The collision, when it finally came, was not a measured embrace, but a cataclysmic explosion of energy, a release of force so violent it dwarfed anything we could hope to witness on Earth. Their icy surfaces fractured, their ancient cores splintered, and the remnants scattered across the emptiness, forming a sprawling cloud of dust and gas, dense and brilliant enough to outshine the surrounding darkness for a brief, luminous moment. The sequence of events in Fomalhaut b's fleeting life resembles the arc of a falling star. The impact unleashed chaos, hurling fragments of the former bodies outward at staggering speeds. The resulting cloud, illuminated by the immense energy of the collision, shone like a newborn celestial fire, a dazzling blaze that would soon be named Fomalhaut b. Yet, this brilliance was no sign of a forming planet. It was ephemeral, transient, a flash of radiance far exceeding the natural glow of any solid body. Ice, dust, and gas were thrown into motion, spiraling outward, creating a spectacle of cosmic destruction and beauty. For a moment, Fomalhaut b gleamed as if it were a star, a luminous wanderer captured within the gravitational field of the Fomal system. Like a comet, it flickered, its shape shifting, its form never solid, never stable. But like all things that burn too brightly, its light began to fade. The dust drifted into the void, cooling with the distance, while the gases slowly dissipated. Particles that once formed a radiant nebula lost cohesion, scattering invisibly across space. The peak of Fomalhaut B's brilliance was brief, a sudden flash that illuminated the heavens before vanishing. Astronomers caught sight of this anomaly in its fleeting glory, eager to understand what appeared to be a nascent planet. They marveled at its brightness, its unusual structure, and the peculiar way it seemed to drift silently in the cosmos. But the glow soon dimmed. The luminous cloud dissipated, spreading thinly across space until all that remained was a ghostly trace of the event. Fomalhaut B's disappearance was gradual, a fading of light and density as the energy from the collision dissipated into the cold expanse of space. The once brilliant beacon became a faint whisper, a memory slowly dissolving into the void. Now, looking back, it becomes clear that Fomalhaut B was never a planet. It was never a stable, solid world orbiting a star. It was the aftermath of cataclysm, a transient monument to cosmic violence. The timeline from collision to luminous flash to slow dispersal reveals the ephemeral nature of celestial phenomena. In the cold immensity of space, nothing lasts. Even the most dazzling flashes of light vanish as swiftly as they appear. Yet the initial classification of Fomalhaut B as a planet was understandable. At first, it appeared as a bright, distinct object in the sky. Its glow, its apparent trajectory, and its position relative to the star Fomalhaut, a star already enveloped in a disk of gas and dust, created a convincing illusion. To astronomers, Fomalhaut B matched the expected characteristics of a planetary body: its apparent size, its orbit, and its reflective brilliance. Perfect timing and the delicate interplay of light created the illusion of a steady, solid world. The deception hinged on perspective. Viewed from Earth at a precise angle, the light scattering off the debris cloud made it appear three-dimensional, solid, and planet-like. The debris, energized by the collision, mimicked the motion of a planetary body, reinforcing the illusion. But beneath this convincing facade lay the truth. Fomalhaut B was debris, a glowing cloud gradually expanding into the emptiness, its luminosity only a temporary effect of scattered light. As the dust cloud dispersed, astronomers' initial conclusions unraveled. The data, once thought definitive, now pointed to something entirely different. Fomalhaut B lacked the mass, gravity, and stability of a planet. Its orbit was irregular, its form inconsistent. What had been a moment of celestial triumph slowly revealed itself as an illusion, a brilliant but transient artifact of cosmic chaos. The story of Fomalhaut B teaches a humbling lesson about observation in space. Distances measured in light years and time-spanning eons create conditions ripe for misinterpretation. Human desire to see solid, tangible worlds can overshadow the reality of fleeting phenomena. The universe offers illusions, fleeting flashes of light that tempt the eye and the mind with promises of permanence, only to fade into nothing. Fomalhaut B was one such illusion. Luminous, spectacular, but ultimately temporary. With continued study, astronomers revisited the observations, reanalyzed the data, and discerned the truth. It was never a planet. It was a momentary spectacle, a ghostly remnant of a violent collision, its existence recorded only in the transient glow of cosmic debris. The initial excitement gave way to understanding, revealing a universe where beauty and destruction intertwine, and where even the most dazzling phenomena are destined to vanish. However, when the initial shock finally ebbed, a new fascination took hold among those who had glimpsed Fomalhaut B. Imagine a planet, ancient and enduring, spinning through the void of space for countless millennia, tracing a steady path around its star. On its surface, possibilities stir, worlds of life, history, and untold mysteries, all quietly unfolding. And then, in a single, catastrophic instant, imagine that world ripped from existence, not billions of years hence, but as if the universe itself had pressed fast forward and placed its death right before our eyes. It was not merely a concept anymore. We had, for perhaps the first time, witnessed the obliteration of a planet. Astronomers who first saw Fomalhaut B were haunted by this vision, a ghost of a world, shimmering briefly, destined to vanish. Could it have once been a thriving planet, a sphere teeming with energy, struck down violently by forces far beyond comprehension? The very notion of planetary destruction is alien to our intuition. Planets, to us, are eternal fixtures, steadfast performers in the grand theater of the cosmos. They follow predictable arcs around their stars for billions of years, seemingly immune to the chaos surrounding them. Gravity acts as the universe's immutable rulebook, enforcing stability and order. But Fomalhaut B challenged that sense of permanence. Its sudden, fleeting flare on our instruments suggested that the cosmos is far less predictable, far less forgiving than we ever imagined. Fomalhaut B appeared as a flicker, a brief glint against the vast darkness of space, and for a moment, it seemed like a planet, until it wasn't. And in that disappearance lay a terrifying possibility that this was no illusion, no trick of light, but a planet caught in the act of annihilation. Collisions in the cosmos are common: asteroids, comets, and small bodies smashing into one another in a ceaseless, brutal ballet. Yet to witness a full-fledged planet, a massive world with its own gravity, atmosphere, and tectonic heartbeat, torn apart is extraordinarily rare. Events of such magnitude reshape solar systems, leaving cosmic fingerprints that endure for eons. What astronomers observed in Fomalhaut B was a sudden flare of light, likely the catastrophic release of energy from a planetary collision. Perhaps a massive impactor struck with unimaginable force, scattering fragments across space, producing a final luminous exhalation before dissolving into nothingness. That a planet could die so violently, so visibly, challenges our assumptions about the universe. Even our own solar system bears scars of primordial chaos. Planets collided, moons fractured, debris filled the void, and yet, witnessing such destruction as it unfolds in real time is almost unimaginable. The evidence, however, is compelling. Fomalhaut B's brightness was too sudden, too extreme, too ephemeral to be mere reflection. It hinted at an event of immense violence, an unprecedented collision producing light far beyond the ordinary planetary glow. The debris would shimmer, scatter, fade, leaving only traces of the cataclysm. And yet the mind struggles to grasp this. Planets are ancient, slow-evolving entities, their lifespans measured in billions of years. To witness a planetary death so fleeting, a brilliant flare visible across unimaginable distances, seems almost fantastical. And still the possibility lingers like a faint echo across the void. Could this flare have been the signature of planetary annihilation? Could Fomalhaut B have shattered in a collision so immense that only the vestiges of its destruction remain, scattered like stardust throughout space? To imagine witnessing such a spectacle stirs something profoundly human. It is a reminder of our fragility, our smallness in the face of cosmic scale. Even seemingly eternal worlds are vulnerable to chaos, to random, violent forces beyond comprehension. Or perhaps it is a revelation that the universe is an ever-shifting stage, where fleeting phenomena, like the sudden disappearance of a planet, are extraordinary moments in an ongoing, unknowable drama. The ultimate truth of Fomalhaut B may elude us forever. Was it truly the death of a planet, or an illusion of cosmic proportions? And yet, in pondering it, we confront a rare and humbling truth. The universe is capable of moments so fleeting, so spectacular, that they challenge our understanding of reality. Fomalhaut B, however brief its existence in our sight, offered a glimpse of the extraordinary secrets the cosmos holds. Our universe is full of mysteries, some vast and enduring, others ephemeral and elusive. When we peer into the night sky, we see distant flickers, ancient worlds faintly aglow, yet their hidden stories remain untold. Occasionally, however, a celestial event pierces the ordinary, making us question what we see. Fomalhaut B was such an occurrence, a sudden burst of light, a planet seemingly appearing and vanishing, a momentary illumination frozen against the black tapestry of space. Was this a once-in-a-billion-years phenomenon, the perfect alignment of celestial timing, observation angle, and cosmic circumstance? Or could it be that such events are more common than we realize, simply unnoticed until the right instruments and circumstances allow us to witness them? Modern telescopes, precise imaging, and advanced simulations have opened our eyes to fragments of cosmic truth once invisible. Yet for all our progress, the majority of the universe remains shrouded, hidden in darkness. How many Fomalhaut Bs are out there, their deaths unseen, their light unrecorded, waiting for a rare convergence of chance to reveal themselves? Perhaps what we observed was merely the surface of a vast cosmic iceberg. Fleeting glimmers, subtle signs of planetary destruction, tiny shifts in light and shadow, once invisible to us, are now captured, cataloged, and analyzed. What seemed impossible a few decades ago has become reality, allowing humanity to witness, even briefly, the final act of a world's life in the unrelenting drama of the universe. Fomalhaut B reminds us that the cosmos is neither stable nor eternal. It is a realm of constant flux, where even the most enduring entities are subject to forces beyond comprehension, where the rarest events can illuminate truths about the fragility, grandeur, and wonder of existence itself. But the question lingers, haunting in its simplicity. How many cosmic coincidences have we overlooked simply because we were in the wrong place at the wrong time, or because our knowledge was not yet sharp enough to recognize the subtle signals that whispered their presence across the void? There is a profoundly humbling elegance in this thought. The universe, with its boundless expanse of stars, nebulae, and planets, teems with narratives, stories that may forever elude our senses, passing by like delicate murmurs in the darkness. Each fleeting event, each subtle celestial movement, like the rise and sudden disappearance of Fomalhaut B, embodies the intricate ballet of forces that choreograph the cosmos and underscores the delicate fragility of existence, even amid the vast, indifferent grandeur of space. Could this ephemeral glimpse into the life cycle of a planet be the opening chapter of a far richer, more intricate cosmic tale that humanity has only just begun to decipher? If we accept that cosmic coincidences are not anomalies but natural phenomena, and that occurrences like the vanishing of Fomalhaut B may be less rare than we imagine, a tantalizing possibility emerges. How many of the universe's hidden wonders continue to escape our perception? Perhaps the true magnitude of activity in the farthest reaches of space dwarfs our comprehension, and our observations barely skim the surface. What if, decades or centuries from now, we look back on Fomalhaut B and realize that what we witnessed was only a fragment of a far larger, more complex tapestry of cosmic events? Could this fleeting encounter be a precursor, a tantalizing hint of the deeper mysteries awaiting discovery? Or was Fomalhaut B simply a singular cosmic accident, a once-in-a-lifetime phenomenon destined to remain enigmatic? What we have learned, more than anything, is that the universe, in its infinite intricacy, safeguards more secrets than our instruments or minds can ever fully capture. The question persists: what else lies concealed in the dark, waiting for an observer fortunate enough to glimpse it? Perhaps the truest enigma is not in what we observe, but in what eludes our vision. Fomalhaut B alone has imparted profound lessons about our cosmos, more so than any other planetary observation of recent years. It has reminded us of both existential truths and technical necessities, particularly the imperative to refine our methods of exoplanet detection to avoid repeating the errors that propelled us on an elaborate pursuit of a planet that may never have existed. When we imagine planets, we tend to picture stability, predictable orbits, vast stretches of emptiness punctuated by steady, reliable celestial bodies, much like the familiar planets of our own solar system. Yet the universe rarely conforms to our expectations, especially when we peer into the distant expanses where stars glow faintly like dying embers and planets are obscured beneath the cosmic veil. Our assumptions falter. Identifying a planet orbiting a star light years away is an undertaking so monumental that it resembles trying to detect a single grain of sand on a beach under a moonless sky. The distances are so immense, millions, billions of miles, that the challenge can feel as intangible as capturing a whisper of wind in one's hand. Exoplanet detection methods are intricate and delicate. The transit method, for instance, it relies on observing the faint dimming of a star's light as a planet crosses in front of it, a tiny shadow drifting over a distant orb. But even this seemingly simple approach is fraught with difficulty. The shadow is minuscule, the alignment critical, and the margin for error almost non-existent. One miscalculation, one missed moment, and the planet remains invisible, hiding in plain sight. The radial velocity method measures the subtle wobble of a star caused by the gravitational pull of an orbiting planet, demanding precision so fine that we are essentially tracking the imperceptible twitch of a dancer's foot across unimaginable distances. Despite these revolutionary methods, the universe often refuses to yield its secrets easily. Our instruments offer only narrow windows into its infinite complexity. Even a single fleeting event can slip past unnoticed, leaving our understanding incomplete. Fomalhaut B exemplifies this challenge. Initially, it appeared as a luminous, unmistakable presence, a beacon of discovery within the relatively nearby Fomalhaut system, approximately 25 light-years from Earth. Its radiant signature captured our imagination, suggesting a planet in its prime, ready to reveal its secrets. But what if this planet was never what we thought it was? Perhaps we were not observing a planet at all, but a transient phenomenon, a cloud of cosmic debris, a remnant of an ancient collision, or a fleeting alignment of cosmic dust caught at the precise angle to deceive our instruments. This is the inherent difficulty of exoplanet detection. Our expectations, our desire to fit observations into known models, can cloud our perception. Reality, when scrutinized more closely, often proves far more intricate than our initial impressions. What distinguished Fomalhaut B was not merely its brightness or location, but the precise timing of the observation. Everything aligned perfectly, creating the illusion of a planet caught in formation or demise, or perhaps both simultaneously. Yet this alignment, so delicate and fleeting, underscores the challenge of cosmic observation. The universe operates beyond our rules, and the signals we perceive are frequently more intricate than our instruments can interpret. Errors are inevitable, but therein lies the true wonder of exoplanet exploration. Discovery is not merely about finding new worlds, it is about confronting uncertainty, questioning whether we have grasped reality or merely glimpsed its shadow. Each detection, each misstep enriches our understanding, revealing the limitations of our perception. The universe is a mosaic of hidden phenomena, entities that slip through the cracks of human observation. Fomalhaut B stands as one of these spectral lessons, a reminder of both the awe-inspiring beauty and the humbling complexity of the cosmos. But why does this matter? Why do we continue to look up at the night sky, to reach for the farthest points of light, even when the answers seem to hover just beyond our grasp? The reason is deceptively simple, yet endlessly intricate. It is curiosity, the restless urge to know, to understand, to probe the hidden corners of existence that drives us onward. Fomal B may have faded from view, vanished into the tapestry of the cosmos, but in its disappearance, it imparted a lesson of immense value. The pursuit of planets, of truths hidden in the stars, is never a straightforward path. It demands patience that stretches across decades, humility in the face of incomprehensible scales, and a willingness to accept that some answers may forever elude us. Yet, it is not merely the discoveries themselves that hold meaning. It is the questions they ignite, the unforeseen directions they reveal. For if we already understood everything, would we even bother to search? When we turn our gaze to the heavens in search of new worlds, the universe offers no easy concessions. It is akin to attempting to decipher a book written in a language half forgotten, with only scattered pages hinting at the plot. Astronomers have wrestled with this cosmic puzzle for centuries, slowly developing tools and methods to tease distant worlds from the overwhelming brilliance of their stars. Each technique is a unique instrument, a lens through which to glimpse the hidden, a combination of insight and limitation. The three primary methods are direct imaging, transit detection, and radial velocity, each revealing a distinct aspect of the cosmos' vastness. Direct imaging is perhaps the most immediately graspable. It is, in essence, the act of pointing a telescope at a star and attempting to capture a planet orbiting nearby. Picture standing on a sunlit beach, attempting to locate a tiny pebble tucked beneath a shadowed rock. The challenge lies in the fact that stars blaze with overwhelming light, easily drowning out the dim glow of any orbiting planet. Astronomers must employ sophisticated techniques to mask the star's brilliance, leaving a slender window through which the faint planetary light can emerge. This method succeeds only with large planets positioned far from their parent stars, giants whose brightness allows them to stand out, as Fomal B once did. Transit detection operates on a subtler principle, like watching for a plane to pass before the sun, momentarily dimming its radiance. Here, astronomers wait for a planet to cross directly between us and its star. The planet's passage causes a tiny dip in the star's light, a fleeting shadow that signals its presence. The Kepler Space Telescope, launched in 2009, relied on this technique to uncover thousands of exoplanets, offering precise measurements of size and orbital period. Yet the method carries limitations. Only planets whose orbits align perfectly with our line of sight reveal themselves. A slight tilt, and the planet remains hidden like a ship gliding just out of view beyond a lighthouse. Radial velocity, or the Doppler method, probes even subtler interactions. Imagine standing at a train station as a train approaches. The whistle's pitch rises as it nears and falls as it recedes. This is the Doppler effect, the same principle astronomers apply to light. A planet's gravitational pull tugs on its star, causing it to wobble slightly. By detecting minute shifts in the star's light as it moves toward or away from us, we can infer the presence of planets too small, too distant, or too dim for direct imaging or transit detection. This method has revealed countless exoplanets, including Earth-sized worlds, each a whisper of possibility in the cosmic expanse. These three methods, powerful yet imperfect, are the primary instruments in the Exoplanet Hunter's toolkit. Fomalhaut B was remarkable because it yielded to direct imaging, a rare triumph for a technique with strict constraints. Its brightness and orbital distance rendered it visible, a luminous figure in a cosmic ballet, yet its fleeting nature reminded us of our limits. Most directly imaged planets are massive gas giants, yet Fomalhaut B was different, a ghostly presence, yet perhaps forming or vanishing in real time, a transient enigma caught in the act. And then the story deepens. The planet's initial detection felt certain, almost inevitable, yet over time it faded, first into an elusive shadow, then seemingly vanished entirely. Questions multiplied. Had it ever been there in a conventional sense? Was it a planet or some other cosmic phenomenon? Was it simply concealed behind veils of dust, slipping from view as the universe unfolded? This uncertainty, this constant dance between knowledge and doubt, is what renders the search for exoplanets so mesmerizing. Every discovery illuminates, but it also exposes how much remains unknown. Fomalhaut B did not truly disappear. We glimpsed a world at the edge of perception, caught in the impermanence of the cosmic rhythm. Perhaps countless other ghost planets drift in hidden orbits, waiting either to be revealed or to fade quietly into oblivion. So, what does it mean to truly discover a planet? Is discovery a beacon of certainty, or is it merely a transient illusion, a fleeting moment we can scarcely hold before it dissolves into the stars? Perhaps the truth lies between these extremes, where science, wonder, and mystery converge. Data is sacred in astronomy, the lifeblood of discovery, the thread by which we unravel the universe's secrets. Each signal from the depths of space is treated with reverence, like a message from the cosmos itself. Yet even data can deceive. Instruments, no matter how precise, sometimes whisper falsehoods. False positives are inevitable, woven into the fabric of exploration. Fomalhaut B exemplifies this delicate tension. For years, it appeared nestled in orbit, a tangible target for human scrutiny. Yet as observations accumulated, doubt crept in. Was it truly a planet, or had we misread the subtle cues, seduced by the thrill of discovery? Its apparent disappearance in the early 2010s underscored how easy it is to see patterns that do not exist, how readily we fall prey to the allure of apparent certainty. Astronomical false positives are not anomalies. They are part of the journey, a reminder that in a universe as vast and intricate as ours, mistakes are inevitable. Yet each misstep deepens our understanding of the cosmos and our place within it. One of the most captivating and cautionary tales in the history of astronomy revolves around the elusive hunt for planet X. In the 1800s, astronomers noticed subtle, puzzling deviations in the orbit of Uranus. These tiny, almost imperceptible irregularities hinted at the gravitational influence of an unseen celestial body lurking somewhere beyond the known planets. For decades, researchers scoured the night sky, combing through telescope after telescope, searching for a shadowy, distant companion to the solar system. Yet, no hidden planet ever appeared. The mystery persisted, only to be unraveled later. The perceived anomalies were not the work of a phantom world, but rather the consequence of the limited precision of the instruments and the incomplete understanding of gravitational physics at the time. The enigma was finally resolved with the discovery of Neptune, a real planet that corrected the orbital calculations and rendered the ghostly planet X obsolete. Centuries later, a modern parallel emerged with the supposed discovery of Nibiru in the early 2000s. Popular media and internet speculation claimed a rogue planet was hurtling toward Earth, threatening catastrophic collisions. In truth, this alarmist scenario sprang entirely from misinterpretations of astronomical data, compounded by sensationalist reporting. Despite the fear and fascination it generated, no evidence ever supported the existence of Nibiru. It was a mirage, a collective illusion born of human error, amplified by conspiracy theories, and spread like wildfire through digital networks. Astronomers have encountered similar false positives when exploring the farthest reaches of the cosmos. In 2004, a team announced the apparent discovery of a new type of star glowing with an intense blue light in wavelengths previously unobserved. For a brief, thrilling moment, it seemed the universe had revealed a wholly new kind of celestial phenomenon. But as observations continued, the excitement gave way to clarity. The blue glow was not a new star, but a distant quasar, its light distorted and magnified by the gravitational lensing of an intervening galaxy. The initial interpretation, though dazzling and poetic, had been a misreading of the cosmos, a reminder that appearances can be deceiving when peering across unimaginable distances. These episodes illuminate the fragile nature of our relationship with the universe. Light traveling from the furthest reaches of space has endured millions, sometimes billions, of years of cosmic interaction. Along its journey, it can bend, scatter, and warp, reshaping the message it carries. Deciphering this light is like piecing together a message that has passed through countless hands, each adding subtle alterations. Even the most skilled astronomers are susceptible to misreading these celestial signals. Every faint flicker, every subtle wobble has the potential to mislead, making false positives an inevitable companion to discovery. The case of Fomalhaut B, or Fomalhaut B, is particularly striking because it arose from direct imaging, a technique far more exacting than the transit or radial velocity methods used to infer exoplanets. Direct imaging requires capturing the faint light of a planet against the overwhelming glare of its parent star, akin to spotting a firefly in the midst of a raging storm. The initial observations suggested a planet perfectly poised in the vast cosmic canvas. Yet, as time passed, doubts crept in. Was it a planet, or merely a transient cloud of dust? Could the data have deceived us, or had we deceived ourselves? The allure of Fomalhaut B lay not in certainty, but in ambiguity, in the haunting beauty of a possibility that might never materialize. This ambiguity underscores a fundamental truth about science. Certainty is provisional. Errors, misinterpretations, and false positives are not failures, but essential elements of the scientific process. They push us to refine our instruments, reevaluate our models, and deepen our understanding of the universe. Each mistaken observation, while initially disheartening, becomes a stepping stone toward greater clarity. They remind us that the pursuit of knowledge is not a straight path, but a journey filled with missteps, corrections, and discoveries that emerge from the very act of questioning. Fomalhaut B exemplifies this dynamic in a profound way. When the Hubble Space Telescope first captured images in 2008, astronomers celebrated the direct sighting of a planet orbiting the bright star Fomalhaut in the constellation Piscis Austrinus. It was a rare, exhilarating achievement, the kind of moment that fuels scientific dreams. Yet within years, closer scrutiny revealed that the supposed planet was not a planet at all. What had appeared as a solid orbiting body was likely a transient cloud of dust or debris, a fleeting illusion on the vast canvas of space. The revelation rippled through the scientific community, forcing a reckoning with assumptions, methodologies, and the very limits of observational astronomy. It reshaped planetary science, serving as a stark reminder that even in the pursuit of certainty, the universe retains the power to surprise. The story of Fomalhaut B, a phantom planet that vanished almost as quickly as it appeared, is more than a tale of human error. It is a narrative of humility, curiosity, and the relentless drive to understand. Every false positive, every shadow mistaken for a planet, teaches us to question, to observe more carefully, to embrace the mystery inherent in the cosmos. The faintest flicker of light may deceive, yet it also guides us deeper into the universe's secrets. In learning from these illusions, humanity moves closer to a truer understanding, refining techniques and models with every revelation. Each misstep is part of the grand adventure of discovery, a reminder that science is not merely about answers, but about the courage to ask questions, to explore the unknown, and to marvel at the ever-changing, ever-mysterious heavens. Fomalhaut B changed more than our understanding of one star system. It transformed the way we approach planetary science. It taught that every observation carries ambiguity, every light signal can mislead, and that the universe often refuses to yield its secrets easily. In the silent dance of the cosmos, there are moments of misinterpretation, fleeting illusions, and spectacular errors that challenge everything we think we know. And yet, in those moments, we learn to look closer, to question more deeply, and to find wonder not just in what is real, but in the possibilities that might have been. One of the most profound lessons drawn from this astronomical misadventure revolves around the very limits of observation itself. Space, infinite in scope and scale, is not merely vast. It is a realm that resists scrutiny, a canvas too immense for our instruments to capture in their entirety. Even our most advanced tools, those heralded as gateways to the cosmos, are intrinsically fallible. They are extensions of human perception, capable, powerful, yet forever constrained by the distortions of perspective and interpretation. Fomalhaut B challenged the assumptions of exoplanet hunters, revealing vulnerabilities in a method once considered nearly flawless. Direct imaging, celebrated as a monumental achievement in astronomy, was no longer untouchable. The very act of photographing a distant planet, a feat once deemed impossible, now carried the haunting possibility of misidentification. What appeared to be a planet could easily be a wisp of interstellar dust, a faint reflection, or a mere optical illusion. The boundary between reality and interpretation proved far more fragile than astronomers had comfortably believed. The saga of Fomalhaut B ignited a surge of innovation. Astronomers began refining their imaging techniques, pushing the boundaries of observational precision and technological capability. Among the most notable breakthroughs were coronagraphs, instruments designed to block the blinding glare of a star to reveal the planets orbiting it. These devices allow scientists to peer into the cosmic shadows, capturing the dim glow of worlds that would otherwise remain hidden. The cautionary tale of Fomalhaut B propelled these technologies to new heights, instilling a commitment to greater accuracy in future planetary discoveries. Yet the transformation was not merely technological. The episode compelled a philosophical shift in planetary science. Previously, there existed a prevailing confidence: see a planet, and it is a planet. Fomalhaut B's disappearance forced a reckoning. Observation is not certainty. Data, however meticulously gathered, can mislead, and assumptions must be questioned relentlessly. Astronomers responded by embracing a culture of skepticism, verification, and relentless refinement. Data could no longer be accepted at face value. Every observation demanded scrutiny. Every signal needed confirmation. Every conclusion remained provisional. Fomalhaut B emerged as a symbol, a reminder that scientific knowledge is provisional, fragile, and subject to constant revision. Discoveries, whether about distant worlds or the universe's very architecture, are fleeting fragments of understanding, never immutable truths. Science, in its most authentic form, demands that we revisit, question, and evolve in our interpretations of the cosmos. The incident also prompted a profound reflection on the methods of exoplanet detection themselves. For decades, astronomers had relied primarily on three techniques: the transit method, observing subtle dimming as a planet crosses in front of a star; radial velocity, measuring the minute gravitational tugs of planets on their host stars; and direct imaging, capturing the planet's light directly. Fomalhaut B called all of these into question, revealing that no method is infallible. Its supposed presence was never a straightforward discovery, but a lesson in the complexity and uncertainty of astronomical observation. This has spurred the development of new approaches, such as gravitational microlensing, where light bends around massive objects to reveal otherwise invisible planets. Each new method is both technical and conceptual, emphasizing that there is no single path to understanding. Discovering a planet is a journey fraught with ambiguity, where answers often multiply into new questions. Fomalhaut B's legacy exemplifies the iterative nature of scientific exploration. Mistakes are not mere setbacks, but catalysts for refining methods and reshaping foundational knowledge. Astronomers, like explorers navigating a dark, uncharted terrain, learn from missteps, recalibrate, and advance with greater insight. At the core of the Fomalhaut B saga lies the technology that mediates our vision of the universe, particularly telescopes and the algorithms that interpret their data. These instruments can detect light from objects billions of light years away, yet the information they gather is far from perfect. Light is subject to interference from Earth's atmosphere, cosmic distortions, and the very nature of the sources being observed. Algorithms attempt to extract meaningful patterns from this noisy data, yet they operate on probabilities and approximations vulnerable to misinterpretation. A cloud of dust, for example, can reflect infrared light in a manner eerily similar to a planet, producing the illusion of an orbiting world. The distance itself compounds the challenge. Fomalhaut B was roughly 25 light years away. At such scales, even the most powerful telescopes struggle to separate objects that are closely aligned in the sky. Stars, planets, and dust clouds can blend into a single indistinct blur, leaving algorithms to decide which features belong together. Wavelength further complicates the picture. Light behaves differently across the spectrum. Infrared passes through dust and gas, revealing hidden structures, while visible or ultraviolet light may scatter or vanish, obscuring details. Fomalhaut B's supposed planet glimmered in the infrared, masquerading as a solid object when in reality it was an ethereal dust cloud. Resolution, another critical factor, determines whether telescopes can distinguish discrete objects or merely see a conflated smear of light. Only the highest resolutions can separate planet from debris, dust from truth. The tale of Fomalhaut B, therefore, is not simply a cautionary note about one failed discovery. It is a study in the delicate dance between observation and interpretation, between technology and fallibility, and between human expectation and cosmic reality. It is also a meditation on the nature of exploration itself. Dust, often dismissed as insignificant, becomes a powerful actor in this cosmic drama. What appears as nothing more than a speck is in fact the residue of countless processes, the whisper of worlds that might have existed, the trace of histories too subtle for casual observation. Fomalhaut B's phantom signature is a testament to how easily perception can be misled when confronting the infinite complexity of space. Its story demonstrates that scientific discovery is never a tidy narrative. It is messy, iterative, and full of surprises. Every misstep, every mistaken identification teaches us not just about the cosmos, but about our own limitations, our assumptions, and our need to continually refine the tools and methods we use to decipher the universe. In the end, Fomalhaut B reminds us that science is as much about the journey as it is about the destination. Each telescope, algorithm, and technique represents a step forward, but no single observation can claim absolute authority. What we see is always filtered through layers of technology, interpretation, and expectation. The cosmic dust that fooled us is both literal and metaphorical, a reminder of the unseen, the overlooked, and the uncertain. And in that uncertainty lies the essence of exploration, the thrill of discovery, and the ever-present invitation to look again, to question again, and to push the boundaries of understanding ever further. However, even with the most advanced instruments humanity has ever built, such as the Hubble Space Telescope, the images streaming back from the cosmos are never entirely flawless. They carry a subtle fuzziness, a graininess, a reminder that no matter how sharp our tools, perfection is elusive. Each photograph is more than a mere picture. It is a puzzle of pixels, a mosaic that must be interpreted through layers of sophisticated algorithms. These digital minds attempt to read between the lines of light, to infer what lies hidden within the patterns of brightness and shadow. Yet, just as an artist's brush might waver, a small blur in the cosmic canvas can transform the story entirely. This is where the enigmatic tale of Fomalhaut B originates, in the hazy frontier between perception and reality, where our certainty meets the unknown. It is in these imperfect glimpses, in the smudged outlines of distant stars and planets, that we encounter the true challenge of exploring the universe. Our instruments are razor sharp, our computations refined, yet our grasp remains tentative. We peer at the heavens, decode their signals with cutting-edge software, and still, much of what we perceive is conjecture. Fomalhaut B was an embodiment of this uncertainty. Initial data suggested the presence of a planet orbiting a distant star. The pixels and patterns hinted at a solid, defined body, a new world waiting to be cataloged. But closer inspection, deeper analysis, and the patience of prolonged observation revealed a different truth entirely. It was not a planet. It was a transient cloud of dust and gas, masquerading as a celestial body through its deceptive brightness and fleeting shape. The vanishing of Fomalhaut B serves as a humbling lesson. Even in an era dominated by sophisticated telescopes and artificial intelligence, our knowledge remains contingent upon the information we can acquire. The universe offers no guarantees. Its data is messy, fragmented, sometimes contradictory. Every discovery is a piece of a puzzle whose edges rarely align perfectly. For stargazers, astronomers, and cosmic explorers, this means accepting ambiguity, embracing the unknown alongside the thrill of discovery. Perhaps the dust clouds themselves are more than illusions. They are the secret keepers of the cosmos, hiding insights that only the most perceptive tools and minds can reveal. If even our best telescopes can be deceived, how do we refine our vision to pierce the veil of uncertainty? The answer begins with the James Webb Space Telescope. The James Webb Space Telescope represents a leap in humanity's ability to observe the universe. It is a marvel of engineering, a sentinel capable of seeing farther and in greater detail than anything before it. Its eyes extend into the infrared, probing the unseen depths of space with the precision of a masterful painter capturing every nuance of a sprawling canvas. The lessons of Fomalhaut B have shaped its design, teaching us about the perils of cosmic misinterpretation and the delicate dance between dust, gas, and the objects we seek. Fomalhaut B was a mirage, an illusion crafted by matter floating in space. The James Webb Space Telescope is designed to see beyond such deceptions. What sets it apart is not merely its size, though its massive segmented mirror is a technological feat in itself, but its infrared sensitivity. Unlike its predecessors, the James Webb Space Telescope can penetrate thick clouds of cosmic dust, revealing the hidden structures within. It can discern the faint heat signatures of distant objects, separating the diffuse glow of debris from the solid warmth of a planet. In effect, it provides a new set of eyes capable of distinguishing the subtle differences that once led astronomers astray. Imagine trying to find a single light in a dense fog through a smeared window. The James Webb Space Telescope is that lens which cuts through the haze, clarifying the true nature of the universe beyond. Yet, its power lies not only in its ability to see in infrared, but in the way it gathers and interprets data. It does not merely capture static images. It constructs multidimensional maps, combining information across multiple wavelengths. This is akin to a painter using a full palette to recreate the richness of a scene, ensuring that every hue, shade, and texture is faithfully represented. By observing a single celestial region in multiple forms of light, the telescope can identify the composition, structure, and movement of clouds, planets, and other objects, revealing their true nature. Perhaps most extraordinary is its capacity to analyze the faintest details of worlds billions of light years away. Distance in the universe is also distance in time. When we observe something far across space, we are witnessing its history, not its present. Fomalhaut B was once a testament to this temporal distortion, a planet that never truly existed as we imagined. The James Webb Space Telescope can mitigate some of this uncertainty by not only collecting light, but dissecting it, breaking it down into a spectrum that uncovers chemical signatures, temperature variations, and structural compositions. It can reveal whether an observed object is solid, gaseous, or a transient formation, a cloud masquerading as a planet. As it turns its gaze to exoplanets, the James Webb Space Telescope promises to redefine our understanding of distant worlds. Combining advanced data processing, collaboration with ground-based telescopes, and refined observational techniques, it will decode the atmospheres, surfaces, and emissions of celestial bodies with unparalleled accuracy. No longer will transient dust clouds easily mislead us. No longer will fleeting mirages dominate our maps of the sky. Instead, the universe will reveal itself with clarity, offering a richer, more definitive portrait of its splendor and complexity. The story of Fomalhaut B is a reminder of the delicate interplay between observation and interpretation, of the limits of our instruments and the vastness of the unknown. With the James Webb Space Telescope, humanity steps forward equipped not only with sharper eyes, but with deeper understanding, prepared to distinguish truth from illusion and to read the cosmic story with a precision that once seemed unattainable. The pursuit of knowledge continues, driven by curiosity, guided by technology, and enriched by the mysteries that remain to be discovered. This, however, is not merely a triumph of technology. It is a triumph of human curiosity, patience, and the willingness to confront the unknown. Fomalhaut B stands as a stark reminder that the universe is not a straightforward book to be read, but a labyrinth of mirrors, a place where light itself can deceive, twist, and dance along invisible curves in the fabric of space-time. What appears obvious from a distance can unravel entirely under closer inspection. Just as beams of starlight bend and scatter across unimaginable distances, so too can our perception of reality be subtly warped, tricking even the most meticulous astronomers. The lessons drawn from this ghostly, ephemeral planet resonate far beyond the initial excitement of discovery. They teach us how to observe with care, to question instinctive interpretations, and to honor the mystery inherent in the cosmos. We learn to read the stars with caution, to sift through streams of data with a reverence that acknowledges the limits of our instruments and minds. In the vast silence of space, where distances stretch beyond comprehension and time flows like an unseen river, what we think we see may only be a fragment of the truth. Yet it is precisely this uncertainty that fuels the fascination of exploring the cosmos. We chase shadows, but in chasing them, we refine our vision. Every false lead, every misidentification, every misstep becomes a lesson, sharpening our instruments, our theories, and our minds. The James Webb Space Telescope continues its voyage with this legacy in mind, promising to pierce the darkness, to illuminate what has long remained hidden, and to challenge our assumptions about what is real. With each new revelation, each layer of interstellar dust or cloud of gas we peel back, new questions emerge. What truths remain veiled, and how much of the universe still lies undiscovered? Fomalhaut B was not just a technical milestone, it transformed our perception of astronomy itself. It reminded us that science is a painstaking, iterative process, built step by deliberate step using the best tools we possess. Yet even in our pursuit of knowledge, the universe often humbles us with its subtle, teasing beauty. Fomalhaut B emerged as a cosmic trickster, defying expectations and demonstrating that even the most advanced scientific minds are vulnerable to illusion. At first, Fomalhaut B seemed to embody every hallmark of a planet: its location within the Fomalhaut system, its apparent motion, its reflective shimmer of light. It was a world that whispered promises of new horizons, of planets beyond our solar system, perhaps even hints of life. But as our technology improved, scrutiny revealed the truth. What we thought was a solid, tangible world was instead a cloud of dust and particles, caught in the star's gravitational embrace. From afar, it appeared like a planet. Up close, it vanished, a mirage dissolving in the light. This revelation, both humbling and enlightening, underscores a fundamental truth. Science is a journey, never a final destination. Fomalhaut B serves as a cautionary tale, emphasizing the limits of observation and the fallibility of our conclusions. Our telescopes, our algorithms, our models are all interpreters of light traveling across inconceivable distances. Yet light can bend, scatter, and shift in ways that confound even the most precise calculations. A single misinterpretation can mislead our understanding, just as a single misstep on a treacherous path can send us astray. Consider the universe as an immense, intricate jigsaw puzzle. Each piece, a fragment of light, a snippet of data, a theoretical insight, is crucial, yet incomplete. We construct a picture slowly, refining our understanding with every added piece. Occasionally, a fragment appears to fit perfectly, only for later evidence to reveal that it was an illusion. Fomalhaut B was such a piece, fitting neatly within expectations but concealing its true nature in the folds of space and dust, deceiving even the sharpest minds. The story of Fomalhaut B reflects not failure, but the essence of the scientific method. Trust in our tools is essential, yet science is not about certainty. It is about continuous questioning, refinement, and the courage to reassess conclusions as new evidence emerges. Fomalhaut B reminds us that human perception, whether biological or mechanical, is fallible. Science is a winding road marked by backtracking, reevaluation, and adaptation. The universe reveals just enough to ignite our curiosity, withholding the full panorama to preserve its mystery. And yet there is profound beauty in this uncertainty. There is a quiet majesty in recognizing our limits, in the humility of discovery. It is through missteps and illusions that we grow, refining questions, sharpening instruments, and expanding understanding. Every revelation, even those that dissolve into disappointment, contributes to the vast tapestry of cosmic knowledge. Fomalhaut B's disappearance is not an endpoint, but a challenge. It demands that we look closer, ask deeper questions, and treat even our brightest findings with gentle skepticism, aware that they too may one day be eclipsed by more profound truths. Fomalhaut B has become more than a cautionary tale. It embodies the delicate balance between knowledge and uncertainty, a reminder that science is a relentless pursuit of understanding, not perfection. Each discovery uncovers new mysteries, akin to standing at the edge of an uncharted sea, where each wave carries both wonder and enigma. From Fomalhaut B, we learn patience, vigilance, and the humility to accept that the universe's complexity exceeds comprehension. Secrets are hidden behind layers of dust, light, and time, often masquerading as tangible realities before slipping into the ether. The cosmos is a master of illusion, a vast, indifferent stage where light bends, stretches, and dances across billions of years to reach our instruments. What we see is often the distant past, a moment frozen in time, not the present. Our minds, wired to seek patterns and impose order, are prone to overlay their own narratives upon the universe's mysteries. We perceive faces in clouds, meaning in chaos, and solidity in what is transient. Advanced technologies, even those of extraordinary precision, are susceptible to the same deceptions. The Hubble Space Telescope's image of Fomalhaut B appeared definitive until scrutiny revealed its ephemeral nature, a reflection of dust and light, fleeting and insubstantial. Science at its core is not certainty, but refinement. It is the relentless pursuit of truth, peeling back layers of illusion to glimpse the deeper workings of the cosmos. Fomalhaut B's story encapsulates this journey, a spectral world that taught us to question, to observe more closely, and to embrace the beauty of uncertainty. Every shadow chased, every fleeting image scrutinized, brings us closer to understanding not just the universe, but our place within it, and the fragile, wondrous tools with which we attempt to perceive it. But how much of what we perceive in the universe is illusion, and how much is grounded in reality? How much of our knowledge is truly ours, and how much is a construct of imagination, pieced together from glimpses and assumptions? For all the sophistication of our instruments, for all the terabytes of data we gather and scrutinize, how much of it is merely the reflection of shadows, echoes of events that happened or might have happened, but are no longer present? The story of Fomalhaut B extends beyond the disappearance of a so-called planet. It reflects the very essence of humanity's pursuit of understanding. It illustrates the relentless drive to grasp certainty, only to confront a cosmos that offers mystery, ambiguity, and fleeting impressions instead. Perhaps therein lies the profound allure of our cosmic quest. The more we uncover, the more acutely aware we become of the vast swaths of knowledge that elude us. Each answer we uncover inevitably births a dozen new questions, and each breakthrough reveals yet another layer of enigma. As we voyage through the stars, chasing photons across vast expanses of space, we must constantly confront this unsettling question. How much of what we perceive is an objective truth, and how much is a playful illusion cast by the universe itself? It would be unfair to label the saga of Fomalhaut B as a debacle. Mistakes were made, certainly, but in those missteps lie lessons of incalculable value. We corrected our misconceptions, yes, but we also gleaned a deeper philosophical insight that our understanding is fragile, fleeting, and infinitely revisable. Consider the elegance in realizing that for a brief instant, humanity believed it had discovered a planet so distant, so magnificent, that it seemed almost like a vision from myth or speculative fiction. What appeared as a world shimmering with promise, a celestial body catalogued and mapped, was ultimately revealed to be no planet at all, but a diffuse cloud of cosmic dust, a mirage in the vast desert of space. Yet the poetry of that illusion is undeniable. Imagine the moment. For a heartbeat in cosmic time, humans believed a new world had revealed itself. It shone brightly, drifting silently through the interstellar void, captured by the lenses of our most powerful telescopes. We gave it a name, traced its supposed orbit, and etched it onto the ever-expanding map of our universe. And then, as swiftly as it had appeared, it dissolved into nothingness. A ghostly cloud, an ephemeral trick of light, a fleeting echo of a possibility that never truly existed. Yet far from diminishing the experience, this transience enhances its beauty. How often do we, in our lives, reach toward the unknown only to discover that it slips just beyond our grasp? Fomalhaut B, like countless other phenomena in the universe, existed for a fleeting instant, a shimmer in the dark that reminds us of the sublime impermanence of discovery. There is an inherent purity in encountering something ephemeral, something impossible to fully possess or comprehend. It reminds us that the cosmos is vast, untamed, and ultimately beyond total human understanding. The episode of Fomalhaut B is not a cautionary tale of failure. It is a celebration of the wonder inherent in exploration. In that brief moment when the first images were captured, scientists experienced awe akin to what any human feels when gazing up at the night sky, pondering the infinite. It was not the planet we anticipated, but a momentary reflection, a fleeting invitation from the cosmos to look closer, to wonder deeper. The universe has a subtle, persistent habit of teasing us. It presents phenomena that seem real, tangible, solid, only to reveal their elusive nature moments later. This tension between certainty and uncertainty is the very essence of what makes the pursuit of knowledge intoxicating. It is like attempting to hold starlight in our hands, an impossibility, yet endlessly captivating. Despite our technological prowess, our telescopes, our algorithms, we remain humbled by the universe's scale and complexity. The truths that remain hidden become part of a larger mystery, compelling us to continue the search. Fomalhaut B serves as a quiet emblem of this dynamic, a testament to the delicate interplay between discovery and illusion. It was never a planet, yet it captured our collective imagination, if only briefly. In that transient vision, humanity glimpsed not a world of matter, but a world of potential, the limitless possibilities that await in the cosmos. There is a strange, haunting poetry in our errors, the acknowledgement that even in mistakes there is beauty, revelation, and insight. What we once classified as a planet was revealed to be dust, an ethereal, insubstantial cloud. And yet that dust encapsulated something far greater. It illuminated our imagination, it reminded us of the fragility of knowledge, and it made tangible the fleeting, ephemeral nature of truth. The discovery was not a failure. It was a lesson, a quiet message from the cosmos, reminding us that clarity is provisional, and that illusion is inseparable from the human quest for understanding. Discovery is inherently recursive. Every answer leads to new questions, ripples that expand endlessly, revealing the profound limitations of comprehension. The mistaken discovery of Fomalhaut B highlights a deeper truth. It is not merely the search for solid answers that defines exploration, but the very act of reaching, of encountering, of experiencing wonder. Fomalhaut B embodies the subtle magic of the unknown. It is not the sharp, definitive revelation of a new world, but the faint, elusive glow of a distant phenomenon, ungraspable, mysterious, and infinitely alluring. It is the silent pull of something just beyond reach, the heartbeat of science itself, the ceaseless interplay between the known and the unknowable. Think of Fomalhaut B, the phantom planet that seized the imagination of an entire generation of scientists and dreamers. For years, it existed in our maps and calculations, a luminous beacon in the inky black of space. We observed it, measured it, and believed in its reality. Yet it vanished as quickly as it appeared, not because the universe was deceitful, but because our understanding was incomplete. What seemed to be a planet was dust, an ephemeral illusion wrought by the complex interplay of light, distance, and technological limitation, and therein lies the beauty of science. In the search for truth, we are challenged by the unknown at every turn. In the pursuit of answers, we confront an ever-expanding web of questions. Wonder is not born from certainty, but from the uncertainty of what remains unseen, unmeasured, uncomprehended. To dismiss Fomalhaut B as a simple mistake would be to overlook the profound gift it represents, the unknown, the ambiguity, and the endless potential for discovery. If the universe were fully known, fully mapped, fully grasped, would we still experience the thrill of looking up, of asking, of reaching? Would we still yearn for that which lies just beyond our horizon? The questions themselves are the fuel of human curiosity. We look to the stars and ask, what is out there? We peer into the abyss of space, wondering if we are alone, and realizing with every answer that we know only a fraction of the truth. This realization is not despairing. It is exhilarating. It is in the liminal space between knowledge and ignorance that the universe reveals itself in its full grandeur, an infinite expanse awaiting exploration. Consider the Hubble Space Telescope, the instrument that first revealed Fomalhaut b. Through its lens, we glimpsed a distant star, and in that image, we perceived what we believed to be a planet, a fleeting apparition that taught us more about the cosmos and ourselves than any certainty ever could. But the telescope, dazzling in its precision and reach, offered us only a fleeting glimpse of the cosmos, a fragment shaped and limited by its own design. Every photon captured, every faint shimmer of starlight is filtered through the complex machinery of human invention. As we uncover more about the behavior of light, the distortions caused by interstellar dust, and the subtleties of data processing, we come to understand that our grasp of the universe is forever mediated, forever incomplete. The tools of science are like the brush of an artist. They paint a picture of reality that is vivid, yet inherently imperfect. And yet it is through this imperfect lens that we glimpse the sublime, that we inch closer to understanding. Fomalhaut b serves as a quiet teacher in this regard. Science is rarely a linear progression. It is a labyrinth, winding through conjectures, dead ends, and tantalizing possibilities. In moments when we feel certainty, when we think an answer has been captured, we are abruptly reminded of our profound ignorance. Within that reminder lies the essence of scientific wonder. The beauty of inquiry is not in definitive answers, but in the infinite potential to question, to explore, and to imagine. In the fissures of our knowledge, in the mysteries we cannot yet solve, resides the universe's true power. Science is often cast as a search for truth, but the act of seeking, the journey itself, is equally vital. The unknown is not merely an absence of knowledge. It is a space where we exist, where imagination and discovery converge. The universe is not designed for comprehension. Its scale is immense, its architecture intricate, its behaviors often bewildering. And that, paradoxically, is what renders it irresistible. Each revelation births further questions. Each resolution unearths deeper enigmas. There is no final destination, only an endless voyage into the unknown. Fomalhaut b, like many cosmic phenomena, slipped from our grasp, elusive and ethereal, leaving only the faintest imprint of what might have been. Yet even in that ghostly trace, there is profound instruction. Appearances can deceive, and certainty is fragile. The universe is not to be conquered. It is to be revered with humility, curiosity, and awe. Whenever we confront a mystery that defies explanation, we should not recoil but embrace it, celebrate it. It is in uncertainty that we discover our place in the cosmos. Without darkness, stars would not shine. Without questions, science would stagnate. In the immeasurable expanse of space, much remains hidden, and it is the pursuit of the unknown that shapes our understanding of existence. Perhaps the grandeur of the cosmos lies not in the answers we uncover, but in the ever-unfolding questions that challenge and inspire us. And here emerges the question of Fomalhaut b's very being. Did it ever truly exist? Existence is so elemental in our daily lives, breathing, moving, thinking, that we rarely pause to reflect. Yet stretched across the cosmic scale, it becomes murky, tenuous, elusive. Fomalhaut b was a specter, a fleeting planet that captured the imagination and dissolved like smoke in the night. Was it real, or merely a construct born of the limitations of our observation? In astronomy, as in philosophy, existence is not absolute. Stars, planets, and moons may seem tangible, but they are bound by cosmic forces far beyond human perception. Things are born, evolve, and vanish on scales that dwarf comprehension. When a planet is observed and then disappears, we confront the fragility of our definitions. Fomalhaut b first appeared in observations in 2008 as a faint, tantalizing speck of light. It was celebrated as one of the most remarkable exoplanets discovered, a signal that worlds beyond our solar system awaited exploration. For a moment, it represented a leap in human understanding, a testament to curiosity and ambition. But as observations continued, the illusion unraveled. Hubble glimpsed it, yet further scrutiny revealed no solid planetary body, only scattered dust and debris. What we thought was a planet was a trick of light and shadow, an optical sleight of hand in the cosmic theater. Does this deception mean Fomalhaut b never existed? Not in the way we expected, but in a different sense, it did. Existence in the universe is not rigid. Stars burn for billions of years before fading. Galaxies collide and vanish. Black holes consume all in their path. Perhaps Fomalhaut B existed fleetingly, shaped by cosmic forces, ephemeral yet real. Its reality was as much in our observation, in our perception and imagination, as in the material universe. Fomalhaut B illuminates the malleability of reality. Our telescopes and instruments, however ingenious, are imperfect. They grant access to the cosmos, yet shape what we see, filtering phenomena through human expectations. In seeking to understand, we inevitably construct illusions. Fomalhaut B was one such illusion, a mirror of our hope and desire to encounter distant worlds, to uncover grandeur beyond Earth. If existence depends on perception, how can we define reality? Is the universe a collection of pre-existing objects, or is it a fluid expanse shaped by observation and imagination? Discovering planets, stars, or galaxies presupposes independent existence, but the cosmos may not be so easily contained. Perhaps understanding is less about revealing fixed truths than about weaving meaning from the unknown. Fomalhaut B may have vanished, yet its lingering mystery continues to inspire. Its fleeting presence forces us to confront the limits of perception and the nature of existence itself. The cosmos is not a ledger of definitive facts. It is a tapestry of wonder, a realm that lives in our minds as much as it does in the stars. Gazing upon the night sky, thinking of Fomalhaut B, we are reminded of existence's fragility, of the universe's indifference to human certainty. Perhaps that is precisely its beauty. The most profound truths may be those that remain beyond reach, shimmering in the periphery like distant stars, always present yet never fully grasped. The question is not whether Fomalhaut B truly existed, but whether its fleeting presence holds meaning. In chasing cosmic riddles, we realize that even illusions teach, even shadows illuminate. We saw something extraordinary, something that inspired wonder. We scanned the infinite blackness, convinced that somewhere, hidden in the void, ultimate truths await, ready to whisper their secrets to those who dare to look. But what if we have been looking in the wrong place all along? What if, when we believed we had glimpsed Fomalhaut B, we weren't witnessing a planet at all, but rather something far more fleeting, intangible, a wisp of cosmic illusion? For years, Fomalhaut B lingered at the periphery of our collective imagination, an enigmatic shadow teasing the edges of our understanding. It was more than a mere planet. It was a tantalizing promise, a whisper from the cosmos that maybe, just maybe, we were drawing closer to the answers that have long eluded human curiosity. Discovered by the Hubble Space Telescope in the year 2008, Fomalhaut B shimmered faintly against the velvet blackness of space, a delicate spark in the night that seemed to murmur, "Here I am." Orbiting a distant star far from our familiar Milky Way neighborhoods, it became a beacon of human ambition, a symbol of our relentless drive to explore, to name, and to stake a claim, however small, in the vast, indifferent cosmos. It represented hope, the eternal human yearning to understand our place in the universe. Yet just as suddenly as it appeared, Fomalhaut B vanished. First, it slipped from the vigilant gaze of Hubble, fading from view despite years of meticulous observation. Then the truth revealed itself with quiet inevitability. The object we had celebrated, that bright moving dot suggesting an exoplanet, was not a planet at all. It was a cloud of debris, a diffuse collection of cosmic dust and gas, a mirage no more tangible than moonlight on a distant lake, dissolving when we reached out to grasp it. And yet the fascination persists. Fomalhaut B may not have been a planet, but its fleeting presence still haunts us. If it was not a world circling a distant sun, then what exactly did we witness? And why does this ephemeral shadow continue to captivate our imagination? Perhaps the answer lies not in the object itself, but in our own yearning. Perhaps what we truly glimpsed was a reflection of ourselves, our ceaseless desire to find meaning in the vast, silent universe. The cosmos offers no guarantees, yet we project our hopes, our questions onto it, searching desperately for answers in the emptiness. In its brief, tantalizing appearance, Fomalhaut B became more than an astronomical curiosity. It became a symbol of exploration itself, a mirror reflecting the deepest human need to seek, to question, to wonder. The universe, however, owes us no clarity. It does not care if we discover or fail, if our questions are answered or eternally deferred. In our compulsion to define, to label, to categorize every faint light we perceive, we risk overlooking a fundamental truth. Some mysteries are meant to endure, just as stars flicker and vanish beyond comprehension. We imbue the cosmos with our longing for certainty, for purpose, and when that longing is left unmet, when illusions dissolve into dust, we confront the profound reality that some answers may never come. Perhaps this is the ultimate enigma Fomalhaut B presents. In searching for meaning, have we misunderstood the nature of the search itself? Maybe our mission was never to locate a distant planet, to confirm the existence of a world far from our own. Perhaps the essence of exploration lies in the questions themselves, in the willingness to acknowledge our ignorance and the beauty of venturing into the unknown. The disappearance of Fomalhaut B does not diminish its importance. It intensifies it. In its vanishing, it becomes something greater than a celestial body. It transforms into a symbol of the impermanence of knowledge, a reminder that the universe is far richer, more mysterious, and more profound than our minds can ever fully grasp. Perhaps the act of seeking, of reaching into the darkness, holds more significance than any discovery. Perhaps it is not the planets we find or the secrets we unravel that matter most, but the relentless curiosity that drives us forward. In this light, Fomalhaut B has never truly disappeared. It survives in the quiet corners of our wonder, in the persistent questions we dare to ask, and in the awe that stirs when we lift our gaze to the night sky. The true discovery may not be the identification of a planet at all, but the realization that the universe, in its infinite complexity, will always leave us a little lost, a little unmoored, and yet infinitely inspired. And therein lies the beauty of it. For all the science, for all the telescopes and instruments, there will always be aspects of the cosmos beyond our reach, existing not as tangible worlds or distant stars, but in the spaces between, in the mysteries that defy our understanding. The essence of exploration resides in those questions, in that enduring curiosity that will never be fully satisfied. So, what did we truly see when our eyes fell upon Fomalhaut B? Perhaps we saw ourselves reaching outward, stretching toward the unknown, seeking to make sense of a universe as unfathomable as it is magnificent. In that act of looking, of daring to wonder, we may have discovered something far more profound than a planet. We may have glimpsed the boundless, enduring spirit of human curiosity itself.